എടുക്കണല്ലേ.
A warm good morning to one and all present here. Pat Riley once commented, "Excellence is the gradual result of always striving to do better." Yes, St. George's College, Aruvithra is at the pinnacle of excellence and excellence today. The PG Department of Mathematics and Statistics deems it a proud privilege to organize an international conference on emerging trends in mathematics and statistics in collaboration with the Kerala Mathematical Association and the IKP St. George's College, Aruvithra. We are really honored to be the virtual platform for the academic deliberations on emerging trends in mathematics and statistics, where the esteemed intellectuals and professors from various international and national institutions meet together and present the papers and innovative ideas. Moreover, we are happy to be the venue for annual conference of Kerala Mathematical Association, and it's a proud moment for us. I welcome the esteemed dignitaries and the participants to the floor. I have an instruction for the participants. Only 100 members can attend this meeting over this bridge. So I request some of you to join through the YouTube link. We can start by seeking the blessings of God Almighty. I invite Rosu Davies for the prayer song.
There shall be showers of blessing. This is the promise of love. There shall be seasons refreshing, sent from the Savior above. Showers of blessing, showers of blessings we need. Mercy, truth round us are falling, but for the showers we plead. Showers of blessing, showers of blessings we need. Mercy, truth round us are falling, but for the showers we plead. But for the showers we plead.
Now, I would like to take the Brahma College Aruvithra, the principal, Dr. George, to the welcome speech.
Esteemed Manager, Reverend Dr. Augustine Palikaparambil, Honorable Dr. Dilesh Shashi IAS, respected Father George Bulligalail Bersar and Course Coordinator, respected Dr. T. Trivikraman, President, Kerala Mathematics Association, respected Dr. Sunny Kuriakos A, Academic Secretary, Kerala Mathematical Association, respected Dr. Gillu Annie John, IQAC Coordinator, Dr. Shiny Jose, Convener, respected other dignitaries, professors, teachers, and dear students. I am really very happy to be here to welcome all of you to the international webinar organized jointly by the PG Department of Mathematics and Statistics, Kerala Mathematical Association, and IQAC of the college. Actually, it is one of the major international webinars conducted in the college during the academic year with the involvement of highly reputed personalities in the realm of mathematics and statistics. Kerala Mathematical Association is an organization established in 1962 to serve the mathematical community comprising students, teachers, and researchers inside Kerala and outside. It has a membership of around 1,000. The association regularly organizes on an average 10 or 12 national or international workshop seminars in different parts of Kerala a year. Dr. T. Trivikraman is currently the president of Kerala Mathematical Association and Dr. Sunny Kuriakos CA is the academic secretary. I am very happy to congratulate all the members of the Department of Mathematics and Statistics, especially Dr. Shaini Jose, the convener of the program, who made earnest effort to materialize this international webinar. Here, my responsibility is to welcome all of you. First of all, I would like to welcome our esteemed manager, Very Reverend Dr. Agustin Balekapparambil, who presides over this function. Our manager is a man of vision and action, and who provides the major source of energy and inspiration for all the activities of the college, both academic and otherwise. On behalf of all present here, I extend you, Very Reverend Dr. Agustin Balekapparambil, manager, a hearty welcome to this function. Our chief guest of the day is Dr. Dileesh Shashi IAS. He is a renowned IAS officer who is very active in the field of administration. He secured 49th rank in the Civil Service Examination 2016. The presence of Dr. Dileesh provides an additional happiness to us in the sense that he is a product of Pala Civil Service Institute, especially under the guidance of Dr. Davis sir. On behalf of all present here, I am very happy to welcome you, sir, to this function. Our course coordinator and bursar, Reverend Father George Bulliganai, is here. The help, assistance, and support from the part of Father in conducting programs like these have been remarkable, and I am very happy to welcome dear Father. The presence of Dr. T. Trivikraman make this function more academic and worthwhile, simply because of the fact that he is one and only notable figure in the field of mathematics. The entire teachers and students in the field of mathematics have always been looked upon him with a great respect and affection due to his academic brilliance. On behalf of all present here, I am very happy to welcome sir to this function. Today's keynote address is to be delivered by Dr. Sunny Kuriakos CA. He has been backbone of the Kerala Mathematical Association. He was the former principal of BPC College, Piron. He served as the General Secretary of Kerala Mathematical Association for 8 years and now serves as the Academic Secretary of the Association. I am very happy to welcome you, sir, to this function. The academic quality of the college largely depends upon the involvement and interference from the part of IQAC, and therefore, I am very happy to welcome our IQAC coordinator, Dr. Jilu Annie John, to this function. Dr. Shaini Jose is the convener, and I know well that Dr. Shaini has been struggling hard for the last several days to conduct such a wonderful international webinar in the college. I am very happy to welcome you, Dr. Shaini, to this function. On behalf of the college, I am very happy to welcome invited speakers, Dr. Thomas Matthew, Dr. Lakshmana Gomadi Nayagam, Reverend Dr. Joseph Varghese, Dr. KK Jose, Dr. Shrija TK, and the conveners of this program, Dr. Elizabeth, Dr. Sibyl Jose, Sri Timmy, and Elizabeth Miss to this program. Let me conclude by welcoming all of you once again. Thank you. Thank you.
Thank you, Reggie sir. With immense pleasure, I welcome Very Reverend Father Dr. Agustin Balekapparambil, the manager of St. George's College, Aruvithra, for the presidential address. Father, please.
Dear and respected Principal Dr. Reggie Varghese, esteemed colleagues, respected guests, dear teachers, students, this is a great honor for me to be a part of this international conference. I understand the hard work the departments of mathematics and statistics put in for bringing this conference a grand success. I appreciate the great work, the hard work of our teachers, especially of Dr. Shaini and her colleagues. Now welcome, dear guests, to our prestigious St. George's College, Aruvithra. We are trying our level best to bring our college to the forefront of academic excellence. Every seminar, every program brings high intellectuals to our college. one way or other way. That way, the atmosphere of the college is really ennobled, enriched, and more oriented towards social problems, academic excellence. Thank you for beloved students, teachers, dear colleagues for organizing such a beautiful program. May God bless you, bless us. Thank you.
Thank you, Father. Now, I feel honored to have with us the Honorable Chief Guest, Dr. Dileesh Shashi IAS, the Sub-Collector of Haveri District, Karnataka, a medical doctor who secured the 49th rank in the civil services and has been appointed as Assistant Secretary in Micro, Small and Medium Enterprises on the completion of Phase 2 training of Lal Bahadur Shastri National Academy of Administration. I would like to welcome you for the inaugural address.
എല്ലാവർക്കും നമസ്കാരം. I think it is an international conference on emerging trends in mathematics and statistics and annual conference of Kerala Mathematical Association. With your permission from all of you, I think I can continue in Malayalam. കാരണം മലയാളത്തിൽ സംസാരിക്കുമ്പോൾ കിട്ടുന്ന ഒരു സ്വാതന്ത്ര്യവും സുഖവും വേറെ ഏത് ഭാഷ സംസാരിച്ചാലും ഒരിക്കലും കിട്ടില്ല എന്ന് വിശ്വസിക്കുന്ന ഒരാളാണ്. കഴിഞ്ഞ 2-3 വർഷമായിട്ട് എനിക്ക് മലയാളത്തിൽ സംസാരിക്കാനുള്ള അവസരം, പ്രസംഗിക്കാനുള്ള അവസരം കിട്ടിയിട്ടില്ല എന്നുള്ള വേറെ സത്യം. 2017 റിസൾട്ട് വന്ന് അരുവിത്തറ കോളേജിലൊക്കെ ഞാൻ പ്രോഗ്രാമിലൊക്കെ പങ്കെടുത്തിട്ടുണ്ട്. സോ അതിനുശേഷം ഞാൻ നാട്ടിലേക്ക് തന്നെ വളരെ അപൂർവമായിട്ട് വന്നിട്ടുള്ളൂ ജോലി തിരക്കുകൾ കാരണം. പക്ഷേ ഇത് ഒരുപാട് സന്തോഷം തരുന്നു. ഇങ്ങനെ ഒരു പ്രോഗ്രാമിൽ ഈ ഒരു സാഹചര്യത്തിൽ ഇങ്ങനെ ഒരു ഓൺലൈൻ മീഡിയം വഴിയാണെങ്കിലും ഇങ്ങനെ ഒരു പ്രോഗ്രാമിൽ പങ്കെടുക്കാനും ഇത്രയധികം ആൾക്കാർ സംസാരിക്കാനും പറ്റിയതിൽ ഒരുപാട് സന്തോഷമുണ്ട് എനിക്ക്. അങ്ങനെ ഒരു അവസരം കിട്ടിയതിൽ ഇതിന്റെ ഭാരവാഹികളുള്ള നന്ദി പ്രകടിപ്പിക്കാൻ അവസരം ഞാൻ വിനിയോഗിക്കുകയാണ്. ബഹുമാനപ്പെട്ട അഗസ്റ്റിൻ അച്ഛൻ, മറ്റു ഭാരവാഹികൾ, അതിൽ പങ്കെടുക്കുന്ന എല്ലാവർക്കും എൻ്റെ നമസ്കാരം. അപ്പോൾ ഇതിൽ ഇന്ന് എന്നിൽ നിക്ഷിപ്തമായിരിക്കുന്ന കർത്തവ്യം എന്ന് പറയുന്നത്, ഞാൻ വിശ്വസിക്കുന്നു ഇതിന്റെ ഉദ്ഘാടനം ചെയ്യുക, അതിൻ്റെ ഒപ്പം തന്നെ ഇതിനൊരു സന്ദേശം എല്ലാവർക്കും കൊടുക്കുക എന്നുള്ളതാണ്. അപ്പോൾ എല്ലാവർക്കും, നിങ്ങൾ പലർക്കും, എനിക്ക് തന്നെ ഇതൊരു പുതിയ അനുഭവമാണ് ഈ രീതിയിലൊരു ഉദ്ഘാടനം നടത്തുക എന്ന് പറയുന്നത്. ഇതൊരു പുതിയ ലോകക്രമമെന്ന് നമുക്ക് വേണമെങ്കിൽ പറയാം. ഇപ്പം ഇതിങ്ങനെ സംഭവിക്കാൻ കാരണം ഈ കോവിഡ് എന്ന മഹാമാരിയാണ്. അപ്പോൾ എപ്പോഴും മാനവരാശിയെ അതിന്റെ ഗതി മാറ്റിവിട്ടിട്ടുള്ളത് ഇതുപോലുള്ള മഹാമാരികളോ ലോകയുദ്ധങ്ങളോ ആണ് ഇപ്പോൾ. അപ്പോൾ അങ്ങനെ ഉണ്ടാകുന്ന ഈ ആപത്തുകളുടെ, വിപത്തുകളുടെ ഒരു ഗുണഫലമാണ് ഇതുപോലുള്ള പുതിയ മാറ്റങ്ങൾ, ലോകക്രമങ്ങൾ നമുക്ക് വിശ്വസിക്കാം. കാരണം സ്വച്ഛന്തമായിട്ട് വിടുന്ന നദിയെ ഒരു പർവ്വതമോ ഒരു പാറക്കെട്ടോ വഴിതിരിച്ച് വിടുമ്പോഴാണ് വലിയ അത്ഭുതങ്ങളായ വെള്ളച്ചാട്ടങ്ങൾ ഉണ്ടാകുന്നതിന്റെ ഗതി വർദ്ധിക്കുന്നത്. അപ്പൊ അതുപോലെ ലോകത്തിന് പുതിയ ആശയങ്ങൾ കണ്ടെത്താനും അത് പരീക്ഷിക്കാനും ഇനിയും മുന്നോട്ട് പോകാനുള്ള അവസരങ്ങളാണ് ഇങ്ങനത്തെ മഹാമാരികളുടെ ഒരു പോസിറ്റീവ് ഫലമായിട്ട് നമുക്ക് കിട്ടും. അപ്പൊ അതിന് അങ്ങനെ ഒരു ശുഭാപ്തി വിശ്വാസത്തോടെ നമുക്ക് നേരിടാം. ഇന്ന് ഈ പ്രോഗ്രാമിൽ പങ്കെടുക്കാൻ വേണ്ടി വിളിച്ചപ്പോൾ ഞാൻ മനസ്സിൽ കരുതിയൊരു കാര്യമുണ്ട്. മാത്തമാറ്റിക്സിനെ പറ്റി ചിന്തിക്കുമ്പോൾ ബാക്കി എല്ലാ ശാസ്ത്രശാഖകളും നമ്മുടെ ജീവിതത്തിൽ ഒരു രീതിയിൽ മറ്റൊരു രീതിയിൽ അതിന്റെ ആപ്ലിക്കേഷൻസ് നമ്മൾ ഉപയോഗിക്കുന്നുണ്ടെങ്കിലും മാത്തമാറ്റിക്സ്, ഗണിതമാണ് എല്ലാവരും നേരിട്ട് അവരുടെ ജീവിതത്തിൽ ഉപയോഗിക്കുന്ന ഒരു ശാസ്ത്രശാഖ എന്ന് പറയും. ഇപ്പോ അടുക്കളയിൽ അരിവേവന എടുക്കുന്ന സമയം മുതൽ എല്ലാ കാര്യത്തിനും നമുക്കൊരു സമയം, ഒരു കാൽക്കുലേഷൻ, ഒരു കൂട്ടലുകൾ, കുറയ്ക്കലുകളെല്ലാം പലപ്പോഴും നമ്മൾ നേരിട്ട് ചെയ്യുകയാണ്. അതുകൊണ്ടായിരിക്കണം സ്ഫടികത്തിലെ ചാക്കോ മാഷ് പറഞ്ഞത്, വിതൗട്ട് ലോകത്തിന്റെ സ്പന്ദനം തന്നെ കണക്കിലാണ്, മാത്തമാറ്റിക്സ് ഇല്ലെങ്കിൽ ലോകം ഒരു വട്ടപൂജ്യമാണ്. ശരിക്കും അതും തിരുത്തേണ്ടിയിരിക്കുന്നു. മാത്തമാറ്റിക്സ് ഇല്ലെങ്കിൽ ലോകം ഒരിക്കലും വട്ടപൂജ്യമാകില്ല. കാരണം പൂജ്യം എന്ന് പറയുന്നത് പോലും മാത്തമാറ്റിക്സിന്റെ സംഭാവനയാണ്. ഒരു മാത്തമാറ്റിക്സ് ഇല്ലെങ്കിൽ ലോകത്തിന് പൂജ്യമാകാൻ പോലും സാധിക്കില്ല. അത്രയ്ക്കാണ് ഗണിതത്തിന്, മാത്തമാറ്റിക്സിന് നമ്മുടെ ജീവിതത്തിലുള്ള പ്രാധാന്യം എന്ന് പറയുന്നത്. അതിനോടൊപ്പം എൻ്റെ ഒരു വ്യക്തിപരമായ അനുഭവം കൂടി പറയാം. പലപ്പോഴും നമ്മൾ മാത്തമാറ്റിക്സ്, ഗണിതം എന്ന് പറയുന്ന വാണിജ്യം അല്ല അങ്ങനെയുള്ള മേഖലയുമായിട്ട് ബന്ധപ്പെട്ട് കിടക്കുന്ന എപ്പോഴും ചിന്തിക്കുമെങ്കിലും ഡോക്ടർമാർക്ക് പൊതുവെ കണക്കുമായിട്ട് വലിയ ബന്ധം ഉണ്ടാകാറില്ല, കണക്കിൽ താല്പര്യമില്ലാത്തവരാണ് പൊതുവെ ആ മേഖലയിലേക്ക് പോകുന്നത് ചിലരെങ്കിലും വിശ്വസിക്കാറുണ്ട്. പക്ഷെ അങ്ങനെയല്ല എന്നാണ് എൻ്റെ അനുഭവം. ഞാൻ കോട്ടയം മെഡിക്കൽ കോളേജിലാണ് MBBS പഠിച്ചത്. അപ്പോൾ അതിനുശേഷം പ്രാക്ടീസ് ചെയ്തിരുന്നു. പാലായിലും മറ്റു പല ആശുപത്രികളിലും പ്രാക്ടീസ് ചെയ്തിട്ടുണ്ട്. ഏകദേശം 2 വർഷത്തോളം കോട്ടയം മെഡിക്കൽ കോളേജിലും പിന്നെ ഇടുക്കി മെഡിക്കൽ കോളേജിലും ലെക്ചറായിട്ടും വർക്ക് ചെയ്തു. അപ്പോൾ ഒരു ഡോക്ടർ എന്ന് പറയുന്ന ഡോക്ടറുടെ അനുഭവം എപ്പോഴും ഡോക്ടർക്ക് ഒരുപാട് കണക്കുകൂട്ടലുകൾ മനസ്സിൽ എപ്പോഴും ചെയ്തുകൊണ്ടിരിക്കുന്ന ഒരാളാണ് ഡോക്ടർ എന്ന് പറയുന്നത്. ഒരു രോഗി വന്നിരിക്കുമ്പോൾ അയാളുടെ ഹൃദയമിടിപ്പിന്റെ കണക്ക്, ശ്വാസോച്ഛ്വാസത്തിന്റെ കണക്ക്, അയാളുടെ രക്തപരിശോധനകളുടെ കണക്കുകൾ എല്ലാം കണക്ക് കൂട്ടിയും കിഴിച്ചും ഒരു നിഗമനത്തിലെത്തി അയാൾക്ക് ഒരു മരുന്ന് തീരുമാനിച്ച് ആ മരുന്നിന് എത്ര ഡോസ് കൊടുക്കണമെന്ന് അയാളുടെ ശരീരഭാരവും മരുന്നിന്റെ പ്രത്യേകതകളും അസുഖത്തിന്റെ രീതികളും മനസ്സിലാക്കി കാൽക്കുലേറ്റ് ചെയ്ത് കണക്ക് കൂട്ടിയാണ് ഓരോ ഡോക്ടറും ഒരു മരുന്ന് എഴുതുന്നത്. അപ്പോൾ രോഗി വരുന്ന സമയം മുതൽ അയാളെ ചികിത്സിക്കുന്ന പറഞ്ഞു വിടുന്ന സമയം വരെ എല്ലാ സമയത്തും ഒരു ഡോക്ടർ ഇങ്ങനെ 100,000 കണക്കുകളാണ് മനസ്സിൽ കൂട്ടിക്കൊണ്ടിരിക്കുന്നത്. അപ്പോ അത്രയ്ക്കുണ്ട് ഓരോ ജീവിത മേഖലയിലും കണക്കിന് ഉള്ള പ്രാധാന്യം. ഇപ്പോൾ ഏറ്റവും അടുത്തിടയ്ക്ക് ഏറ്റവും റീസെന്റ് ആയിട്ടുള്ള ഒരു ഡെവലപ്മെന്റ് നമ്മൾ പറയുകയാണെങ്കിൽ, ഈ കോവിഡ് എന്ന മഹാമാരിയെ നമ്മൾ ചെറുത്തു നിൽക്കാൻ ഉപയോഗിക്കുന്നതിൽ പ്രധാനപ്പെട്ട ആയുധം എന്ന് പറയുന്നത് നമ്മുടെ അതിന്റെ ഡേറ്റയും അതിന്റെ അനലൈസിസും സ്റ്റാറ്റിസ്റ്റിക്സുമാണ്. നിങ്ങൾ ചിലർക്കെങ്കിലും അറിയായിരിക്കും, പ്രത്യേകിച്ച് ഞങ്ങൾ അഡ്മിനിസ്ട്രേഷനിൽ നിൽക്കുമ്പോൾ ഞങ്ങൾക്ക് വളരെ കൃത്യമായിട്ട് അടുത്തറിയാൻ സാധിക്കുന്നുണ്ട് രോഗത്തിന്റെ ട്രെൻഡ് എങ്ങനെയാണ്, എത്ര രോഗികൾ ഉണ്ടാകുന്നുണ്ട്, എത്ര പേർക്ക് കുറഞ്ഞു. ഇപ്പോ വളരെ കോമൺ ആയിട്ട് തന്നെ ആൾക്കാർ ഉപയോഗിക്കുന്ന ഒരു കാര്യമാണ് കർവ് ഫ്ലാറ്റ് ആകുക, രോഗികളുടെ എണ്ണം കുറയുന്നു, കർവ് ഫ്ലാറ്റ് ആകുന്നതൊക്കെ വളരെ സാധാരണക്കാർ പോലും ഇക്കാലത്ത് ഉപയോഗിച്ചു തുടങ്ങിയിരിക്കുകയാണ്. അപ്പോൾ മാത്തമാറ്റിക്സിന്റെ ഒരു ഇൻഫ്ലുവൻസ്, സ്റ്റാറ്റിസ്റ്റിക്സിന്റെ ഇൻഫ്ലുവൻസ് ആണ് നമ്മളിവിടെ കാണുന്നത്. ഈ രോഗം എങ്ങനെ പോകുന്നു അതിന്റെ ഒരു മാർഗം പ്രെഡിക്റ്റ് ചെയ്യാനാണെങ്കിലും അതിനെ എങ്ങനെ നേരിടണം തീരുമാനിക്കാനാണെങ്കിലും ഒക്കെ നമ്മൾ ഉപയോഗിക്കുന്നത് ഈ നമ്മുടെ മാത്തമാറ്റിക്കൽ അനാലിസിസ് അതുപോലുള്ള ടൂൾസ് ആണ്. അപ്പോ രോഗികളുടെ ജീവൻ രക്ഷിക്കാൻ പോലും, മാനവരാശിയെ മൊത്തം സംരക്ഷിച്ച് പിടിക്കാൻ പോലും കഴിവുള്ള ഒരു ശാസ്ത്രശാഖയാണ് മാത്തമാറ്റിക്സ് എന്നാണ് നമ്മൾ ഇതിൽ നിന്ന് മനസ്സിലാക്കേണ്ടത്. അപ്പോ അങ്ങനെ വളരെ പ്രധാനപ്പെട്ട ഒരു മേഖലയിൽ ഈ പ്രതികൂല സാഹചര്യത്തിലും നൂതനമായ ഇതുപോലുള്ള സംവിധാനങ്ങൾ ഉപയോഗിച്ച് ഇതുപോലൊരു സെമിനാർ, ഒരു പ്രോഗ്രാം നടത്താൻ ഇതിന്റെ ഭാരവാഹികളും മറ്റ് സംഘാടകരും കാണിച്ച ആ ഒരു ആർജവത്തിനെ ഹൃദയം തുറന്ന് അഭിനന്ദിക്കാൻ ഞാൻ ഈ അവസരം വിനിയോഗിക്കുകയാണ്. ഒപ്പം ഇതില് sorry, I got someone saying that sir, English please. I hope sorry that some of you didn't understand that I am speaking in Malayalam, because I was so excited to use Malayalam, because after that, after a long time, I got a chance to speak in Malayalam. So I was excited in that aspect. So simply for others who didn't understand this Malayalam speech, I will just tell you briefly certain things. The importance of mathematics and statistics in the administration issues nowadays, because in these days we are managing a disease like a pandemic like COVID with the help of mathematical and statistical tools. You can understand that even now laymen are using the terms like flattening of the curve, controlling the numbers and such kind of terms. Daily we are analyzing all the data as like the number of the patients, how many are recovered and how many are on the incubation period. We are getting all data and statisticians are analyzing this data and they are providing us graphs and other things to predict the curve and how the number of patients increase and how we can manage all these things. So that's the level on which mathematics can be applied to save the lives of millions. So in that aspect, conducting a seminar on the emerging trends of mathematics and statistics will be a great help for the not only for the group of students who are joining here, I think, but for the entire humanity. We have to think it in that large aspect. So I hope it definitely will help you all, and I would fully congratulate all the coordinators of this program to arrange a program like this in this scenario. We have utilized all the facilities, brought this much people to the platform. I'm really happy to see you all here. So hope this program will be a great success and will achieve its goal. So I really congratulate you all. And today my responsibility to inaugurate this function. So I use this opportunity to announce that I inaugurated this event through this platform. So thank you all. So വീണ്ടും മലയാളത്തിലേക്ക് തിരിച്ചു വരാം. എന്നിൽ നിക്ഷിപ്തമായിരിക്കുന്ന കർത്തവ്യം പോലെ ഈ പ്രോഗ്രാം ഉദ്ഘാടനം ചെയ്തതായി പ്രഖ്യാപിച്ചുകൊണ്ട് ഞാൻ എൻ്റെ വാക്കുകൾ ചുരുക്കുന്നു. നന്ദി, നമസ്കാരം.
Thank you, Dilesh sir. With great pleasure, I invite Dr. T. Trivikraman who has made important contributions to topology, fuzzy mathematics, and several other areas of mathematics. He is also the president of Kerala Mathematical Association and the formerly professor of CUSAT. Now, I invite him to address us. Sir, please.
പ്രിയപ്പെട്ടവരെ, എനിക്ക് പറയാനുള്ളത് ഞാൻ മലയാളത്തിലേ പറയുള്ളൂ. കാരണം കേൾക്കാനുള്ളവരൊക്കെ മലയാളികളാണെന്നാണ് എൻ്റെ വിശ്വാസം. പുറത്തുനിന്ന് ആരെങ്കിലും ഇല്ലെന്ന് വിചാരിക്കണം. ഞാനൊരു ഗണിത അധ്യാപകനായിരുന്നു കഴിഞ്ഞ 52 കൊല്ലം. 21ാമത്തെ വയസ്സിൽ തുടങ്ങി 73ാമത്തെ വയസ്സ് വരെ ഗണിതാധ്യാപകനായിരുന്നു. അതുകൊണ്ട് തന്നെ അപ്പോൾ പഴയ ഒരു കാര്യം കൂടെ ഓർക്കട്ടെ. ഞാൻ പ്രീ യൂണിവേഴ്സിറ്റി, അന്നത്തെ പ്രീ ഡിഗ്രിക്ക് പകരം പ്രീ യൂണിവേഴ്സിറ്റി കഴിഞ്ഞിട്ട് എനിക്ക് സാഹിത്യത്തിലുള്ള താല്പര്യം കാരണം മലയാളം BA-ക്കുള്ള അപേക്ഷാ ഫോറമായിട്ട് പ്രിൻസിപ്പലിന്റെ മുമ്പിൽ ചെന്ന് നിന്നു. അപ്പൊ അദ്ദേഹം പറഞ്ഞു, അത് വെട്ടിത്തിരുത്തി സ്വന്തം പേരുണ്ട്, മാത്തമാറ്റിക്സിനാക്കി. എന്നിട്ട് പറഞ്ഞു, താൻ മാത്തമാറ്റിക്സ് പഠിച്ചാൽ മതി, മലയാളം തന്നെത്താൻ പഠിച്ചാൽ മതി എന്ന് പറഞ്ഞു. ഞാനത് എപ്പോഴും ഓർക്കാറുണ്ട്. കാരണം എൻ്റെ മലയാളത്തിലുള്ള താല്പര്യം മാത്തമാറ്റിക്സിനും മാത്തമാറ്റിക്സിലുള്ള പരിചയം മലയാളത്തിലും പരസ്പരം പ്രേരകവും പൂരകവുമായി ഇരുന്നിട്ടുണ്ട് എന്നാണ് എൻ്റെ അനുഭവം. അതുകൊണ്ട് തന്നെ എനിക്ക് അങ്ങേയറ്റം സന്തോഷമുണ്ട്. ഈ 32 കൊല്ലത്തോളം ഞാൻ ഗണിതാധ്യാപകനായിരുന്നു. തുടക്കത്തിൽ മാർ അത്തനേഷ്യസ് കോളേജ് കോതമംഗലത്തിലും, പിന്നീട് 26 കൊല്ലം കൊച്ചി യൂണിവേഴ്സിറ്റിയിലും, അത് കഴിഞ്ഞ് റിട്ടയർ ചെയ്തതിന് ശേഷം സെന്റ് ജോസഫ്സ് കോളേജ് ഇരിഞ്ഞാലക്കുട, കണ്ണൂർ യൂണിവേഴ്സിറ്റി എന്നിവിടങ്ങളിലും എല്ലാമായിട്ട് 52 കൊല്ലം ഗണിതാധ്യാപകനായിരുന്നു. അപ്പോൾ നിരവധി പേരെ വേണമെങ്കിൽ വഴി തെറ്റിച്ചിട്ടുണ്ടെന്ന് പറയാം, അല്ലെങ്കിൽ നേർവഴിക്ക് കൊണ്ടുവന്നിട്ടുണ്ടെന്ന് പറയാം. ഏതായാലും ഗണിതത്തിൽ താല്പര്യം ഉണ്ടാക്കാൻ കഴിഞ്ഞിട്ടുണ്ട് എന്നാണ് എൻ്റെ വിശ്വാസം. അതിൻ്റെ ഒരു പ്രോഡക്റ്റാണ് ഈ കേരള മാത്തമാറ്റിക്കൽ അസോസിയേഷൻ തന്നെ എന്നാണ് എൻ്റെ വിശ്വാസം. ഈ അസോസിയേഷൻ വളരെ ഭംഗിയായിട്ട് നടത്തുന്നതിൽ എൻ്റെ സുഹൃത്തുക്കളും ശിഷ്യന്മാരും അങ്ങേയറ്റം സഹായിച്ചിട്ടുണ്ട്, സഹായിക്കുന്നുണ്ട്. അസോസിയേഷൻ്റെതായിട്ടുള്ള ഒരു ജേണൽ പ്രസിദ്ധീകരിക്കുന്നുണ്ട്, ബുള്ളറ്റിൻ ഓഫ് കേരള മാത്തമാറ്റിക്കൽ അസോസിയേഷൻ. അന്താരാഷ്ട്ര അംഗീകാരം നേടിയിട്ടുള്ളതാണ്. അതിൽ ധാരാളം പബ്ലിക്കേഷൻസ് വരുന്നുണ്ട്. നിങ്ങൾക്ക് ആർക്കെങ്കിലും പേപ്പറൊക്കെ പബ്ലിഷ് ചെയ്യാനുണ്ടെങ്കിൽ അതിലേക്ക് അയച്ചു കൊടുക്കാം. സ്വീകാര്യമാണെങ്കിൽ അതിൽ പ്രസിദ്ധീകരിക്കുകയും ചെയ്യും. ഏതായാലും ഇന്ന് ഈ സെമിനാറിൽ പങ്കെടുക്കാൻ, അധ്യക്ഷൻ എന്നുള്ള നിലയ്ക്ക്, പ്രസിഡന്റ് എന്നുള്ള നിലയ്ക്ക് പങ്കെടുക്കാൻ പറ്റിയതിൽ എനിക്ക് അങ്ങേയറ്റത്തെ സന്തോഷമുണ്ട്. സാധാരണ ഞാൻ ഈ ഗണിതശാസ്ത്രത്തിനെ പറ്റിയുള്ള സെമിനാറുകളിൽ കോട്ട് ചെയ്യുന്ന ഒരു ശ്ലോകമുണ്ട്, അത് പറഞ്ഞേക്കാം. യഥാശിഖ മയൂരാണാം നാഗാനാം മണയോരത തദ്വത് വേദാംഗശാസ്ത്രാണാം ഗണിതം മൂർധനിസ്ഥിതം. മയിലുകൾക്ക്, മയൂരങ്ങൾക്ക് ശിഖ, അവരുടെ ശിഖ ഏതുപോലെയാണോ, നാഗങ്ങൾക്ക്, പാമ്പുകൾക്ക് മണി ഏതുപോലെയാണോ, അതുപോലെ ശാസ്ത്രങ്ങൾക്ക് എല്ലാം മൂർധാവില, എല്ലാം മുകളിലായിട്ട് ഗണിതം സ്ഥിതി ചെയ്യുന്നു. അത് ഞാൻ വിശ്വസിക്കുന്നു, അത് ശരിയാണെന്ന് ബോധ്യപ്പെട്ടിട്ടുമുണ്ട്. ഒരു ഗണിത അധ്യാപകനാവാൻ കഴിഞ്ഞതിൽ എനിക്ക് അങ്ങേയറ്റത്തെ സന്തോഷമുണ്ട്. ഒരുപാട് ശിഷ്യന്മാരുണ്ട്, അവരെല്ലാം എന്നെ ഓർക്കുന്നുണ്ടാവും, എന്നെ സ്നേഹിക്കുന്നുണ്ടാവും എന്നാണ് എൻ്റെ വിശ്വാസം. ഇതിൽ കൂടുതലൊന്നും തൽക്കാലം പറയാനില്ല. നിങ്ങൾക്ക് എല്ലാവർക്കും നന്ദി, നമസ്കാരം.
We are extremely honored with the presence of Trivikraman Sir, President of KMA, formerly Professor of CUSAT, in the midst of us. It's indeed my pleasure and proud privilege to thank Trivikraman Sir from the core of my heart for his benign presence in the international conference. Thank you, sir. Now, I would like to invite Dr. Sunny Kuriakose A, Academic Secretary KMA, Professor and Dean of CUSAT Angamali, for the keynote address. Sir, please.
Am I audible?
Yes, sir.
Okay, thank you. Good morning, all of you. Principal of the college, Dr. Rajiv Burgess. Manager of the college, Very Reverend Dr. Augustine Palakipparambil. Today's guest of honor, Dr. Dilesh Shashi, IAS. Dear Trivikraman sir, Father George, Dr. Jilu, and the coordinator of this 3 days international webinar, Dr. Shaini Jose, esteemed resource persons from across the world, dear participants and delegates, dear friends, a very warm good morning to each one of you. As you all know, this 3 days international webinar is being organized by the Department of Mathematics of St. George College, Arivithara, under the leadership of Dr. Shaini Jose and the IQAC, Internal Quality Assurance Cell of the college, and in association with the Kerala Mathematical Association. Just now we heard from our TT sir, Trivikraman sir, that the Kerala Mathematical Association is a dream child of Dr. T. Trivikraman sir. As the students all know that KMA or Kerala Mathematical Association is the only professional body in Kerala imparting mathematics education to the students, teachers, and the research scholars. And it is helping many institutions in conducting national and international seminars, workshops, etc., etc. But you know, the present pandemic has completely stalled each one of us, our activities, in such a way that the conventional mode of delivery, the conventional mode of conducting this type of conferences and seminars is not at all possible. And we are now in the virtual mode. As the guest of honor rightly pointed out, if there is a constraint before us, it is not good to stop all our activities, but to make it as a jumping pad, an opportunity to do better things. So I especially congratulate the Department of Mathematics and the St. George College, Arivithara, and its management, in particular the manager Achan, and the principal and the Department of Mathematics of Arivithara College for venturing into conducting this type of 3 days international webinar. It is not seminar now, it's a webinar now. Okay. Dear friends, you know the significance of Kerala Mathematical Association in the present time. Now, as Sir Trivikraman sir has pointed out, the association has a library and a research center at Kottayam, and it is publishing an international journal named Bulletin of Kerala Mathematical Association, and also it is helping the member institutions for conducting various programs. When the syllabi of a particular university is changed, when a new syllabus is introduced, a new paper is introduced in mathematics, then KMA is always there to help the teachers and the professors. We used to conduct very many workshops, weekend seminars and workshops to educate and to help the mathematics fraternity of Kerala. So KMA, we all do in a very harmonious way. There is no head office for the KMA. There is no permanent office for KMA, but we are all, our houses and our offices are KMA's offices. So I don't know how to thank Dr. T. Trivikraman, his valuable contribution in upbringing this association. even though it was started in 1960s, the association was partially dead during a long period. But due to the relentless effort of Trivikraman sir and many other his students, the association has grown to this present status. So the glory and name of the name and fame of KMA, if at all it is there, is indebted to Trivikraman sir. It was his contribution, it was his encouragement made all these things possible for KMA. We have a huge member base. We have international members, we have national members, we have state members, we have student members as well. Dear students, if any +2 students are listening to this particular program, you are also invited to join the association and become members of the association. Let us join our heads together and join hands in hands and make mathematics education popularizing, most popular in the state of Kerala and elsewhere. I don't know what should I talk as a keynote address. We have a very eminent resource persons in the list, a galaxy of eminent resource persons we have. The first talk is by Lakshmana Govindan Nayagam. He is the head of the Department of Mathematics in the NIT Trichy. And also there are so many other resource persons from across the globe. And this particular 3 days conference webinar is on the recent emerging trends in mathematics and statistics. So there are some sessions set apart for statistics lectures and certain lectures for in the mathematics. And by the way, there is no difference between mathematics and statistics, as I know. But still, there is some difference we are all imposing. Thereby, we have included the sessions from both mathematics and statistics. One word to the head of the department. One word about the head of the department, Dr. Shaini Jose. She has been working meticulously for weeks and weeks for conducting this particular 3 days webinar. You know, nowadays the communication is online. That's okay, but still we have to conduct. We have to do a lot of homework in conducting this seminar. And as I know, it is not a PG department in the college, but still with the limited resources, Shaini Miss has done wonderful work. I especially congratulate the organizing committee headed by the head of the department, Dr. Shaini Jose, and I special kudos to the organizing team. And dear friends, we have various memorial lectures we have arranged in KMA. And during these 3 days, there are 3 memorial lectures presented. One is Saraswati Amma Memorial Lecture. The other is, she was a very famous historian in mathematics. And the second one is Dr. K.R. Unni Memorial Lecture. Dr. K.R. Unni was a professor in Math Science Chennai, and also he was one of the presidents of Kerala Mathematics Association. And the third one is Dr. Wasir Hassan of the Memorial Lecture. He was the head of the Department of Mathematics in Cochin University of Science and Technology. And honoring these 3 persons, we have they are no more with us. Honoring this, paying homage to these 3 eminent mathematicians, we have instituted memorial lectures by KMA. And another endowment lecture, very important and very serious endowment lecture, we have instituted in the name of Dr. T. Trivikraman. And we are conducting this annually. And this time also, along the Kerala Mathematical Association annual conference, this Professor T. Trivikraman Endowment Lecture also is arranged. Therefore, KMA is doing a lot of work. But this pandemic has deterred us from many things. We used to have the send-off meeting to all the retired staff from the mathematics fraternity all over Kerala. We used to invite them, and they used to come and have attend that meeting. But this time we could not do that due to the pandemic, and also last year also we could not do it. So when the situation becomes normal, we will definitely hold a meeting to honor the retired teachers. And with these words, I would like to offer all my felicitations to the entire program. I am very sure that the program will be highly fruitful and productive, and the program will be very much resourceful, and consequently many research scholars in the area of mathematics and statistics will benefit out of the deliberations done here. We can always have interactions in either the Google Meet or by mail. You can interact with the resource persons, and as Google Meet has some limitations, the only limited number of participants are included in the Google Meet, and all others can access the YouTube link. So by these words, I once again congratulate all the organizing committee. Special thanks to the St. George College, Arivithara, for hosting this type of a great event, which could be memorable in the history of St. George College. And also special thanks to Dr. Shaini Jose for her meticulous efforts for this particular 3 days webinar. Thank you so much.
Thank you, Sunny sir. I invite Reverend Father George Pulikalai, the bursar and the course coordinator of St. George's College, Arivithara, for felicitation. Father, please.
Good morning. Can you hear me?
Yes, sir.
Respected manager, Very Reverend Dr. Augustine Palikaparambil, College Principal Dr. Reggie Varghese Mekadan, today's chief guest Dr. Dileesh Shashi IAS, Dr. T. Trivikraman sir, Dr. Sunny Kuriakos, and other dignitaries on this online platform, dear friends. It's a proud moment for the college to conduct an international conference in association with KMA, Kerala Mathematical Association. And I take this opportunity to congratulate our faculties of the department and members of KMA on their sincere efforts and hard work to realize this event. Even in the midst of the struggles of this pandemic, COVID pandemic, the department and association take such an initiative. The participants of the program show interest to join is a very big thing. I personally appreciate and prize your efforts and presence. To conclude, I wish you all the very best and success to this program. Thank you very much.
Thank you, Father. Now I invite Professor Jilu Annie Joan, IQAC coordinator, to deliver felicitation. Ma'am, please.
Esteemed manager, Reverend Dr. Augustine Palikaparambil, the principal of the college, Dr. Reggie Varghese Mekadan sir, the chief guest of the day, Dr. Dileesh Shashi IAS, Dr. T. Trivikraman sir, the president KMA, Dr. Sunny Kuriakos, academic secretary KMA, delegates, friends, and students. It's really heartening that St. George's College, Arivithara has not compromised on quality in these days of confinement and confusion caused by the COVID-19 pandemic. We have been quite vibrant these days with the above progress, both academic and academic every week. And it's really promising that the Department of Mathematics has come up with an international conference in order to cope with the matchless historical reality of the pandemic. I know that it's a fruit of the joint effort of the department, especially the one led by Dr. Shaini Jose, who had been toiling for over a month to materialize this dream of hers. I'd like to take this opportunity to appreciate the Department of Mathematics and their team mathematics, the students, everyone who cooperated with this venture. I'm sure that the platform will be visited by virtually visited by eminent mathematicians, and there'll be a lot of discussion. I wish you.
Thank you, ma'am. There is an important announcement. Our first lecture starts immediately after this meeting. Also, the first session is Professor K.R. Uni Memorial Lecture by the resource person, Dr. V. Lakshmana Gomadi Nayagam, HOD of Mathematics, NIT, Trichy. Next, I would like to invite Dr. Shaini Jose, the convener ICETMS 2020, to deliver a vote of thanks.
Good morning. Can you hear me?
Yes, ma'am.
President of the meeting, Lady Reverend Dr. Agustin Palakapparambil. Today's chief guest, Dr. Dinesh Shashi IAS. Respected Principal, Dr. Reggie Varghese Mekaden. Our beloved Dr. T. Trivikraman, President KMA, and our beloved Dr. Sani Kudiakos, Academic Secretary KMA. Reverend Dr. George Puligalai, Basar and Course Coordinator, Dr. Jilu Annie John, IQSC Coordinator, invited speakers, Dr. Lakshmana Gomadi Nayagam, Dr. K.K. Jose, Reverend Dr. Joseph Varghese, Dr. Thomas Matthew, Dr. Shrija T.K., respected members of KMA, beloved teaching and non-teaching community of this college, members of the organizing committee, ICETMS 2020, beloved students and well-wishers of this college. Now we are all at the successful culmination of the official inauguration of the International Conference of Emerging Trends in Mathematics and Statistics, organized by the PG Department of Mathematics and Statistics in collaboration with KMA and the IQSC of St. George College, Arutara. This is a moment of utmost pride and achievement for both the college and the Department of Mathematics and Statistics, since we could organize an international conference on a virtual platform, even at the outbreak of COVID-19 pandemic. We are immensely gratified with the presence of great mathematicians, intellectuals, and research scholars from the reputed institutions across the globe. May I use this opportunity to extend my sincere thanks to the backbone of this college, our beloved manager, Very Reverend Dr. Agustin Palakapparambil, for presiding the meeting. Our chief guest, Dr. Dinesh Shashi IAS, Assistant Commissioner, Haveri District, Karnataka, a vibrant IAS officer. Sir, we are really proud of your presence midst of us. I extend my heartfelt thanks to you, sir. I have no words to express the support given by the principal, Dr. Reggie Varghese Mekaden. He is the brain behind all the programs in this college. Every day we have webinar only because of his support. I extend sincere thanks to you, sir. Now you, TD sir, the whole lot of your students are also participating in the conference, and I'm happy to see the father-like figure. Thank you, sir, for your presence and blessings. Dr. Sani Kudiakos also present here. He is the brain behind this program. He is the backbone of KMA. I extend sincere thanks to you, sir. Now I extend my thanks to Reverend Father George Puligalayil, Barsar and Courts Coordinator, and to Dr. Jilu Annie John for your beautiful words, encouraging words. Thank you so much. May I use this occasion to remember with thanks our invited speakers, Dr. Lakshmana Gomadi Nayagam, Dr. K.K. Jose, Reverend Dr. Joseph Verghese, Dr. Thomas Matthew, Dr. Shija T.K. Thanks to you all, sirs. Now I extend my sincere thanks to all the members of KMA, my friends and students for your presence. Above all, members of the organizing committee, especially Dr. Sibulios, Dr. Tommy Talavayalil, Srimati Elizabeth Augustine, Sri Benjit, and Sri Jindu for your strong support. Thank you all. Thank you.
Thank you, Shainima. Our official meet is over. Now we are entering the next section. We have some instructions for the participants. If you have any doubts or questions regarding the
അമലു പറയുന്ന കേൾക്കാൻ പറ്റുന്നില്ലല്ലോ ആൻമേരി കണ്ടിന്യൂ ചെയ്തേ
പക്ഷെ ആൻമേരിയുടെ നെറ്റ് ലോസ്റ്റ് കട്ടായി പോയതാ.
Sorry, sir. We have some instructions. If you have any doubts or questions, you can write it in the chat box and it will be discussed at the end of the session. Our first session is Professor K.R. Unni Memorial Lecture. About him, Professor K.R. Unni was the Vice President and member of the Council for Calcutta Mathematical Society for many years. He was also a member of the Calcutta Mathematical Society and Journal of Mathematical and Physical Sciences. Professor Unni was the president of Kerala Mathematical Association during his last 3 years. His support and encouragement had been highly used for the growth of association. I welcome Dr. Sunny Kuriakos, the Secretary of KMA, for welcoming the resource person, Dr. V. Lakshmana Gomadi Nayagam, of today's session. Please, sir.
Good morning to all, one and all. This is Gomadi Nayagam, right, from NID Softly. Is it audible?
Okay, sir.
Madam, I am not finding the presentation mode, madam. So
We can hear you, sir.
but you can hear me, okay? So I have to present,
We can see you. Quantum theory.
Yes, that is correct. Okay, so my video is coming, right? The presentation, I'm not getting the presentation mode. So how to do it now? I will just go out and join, madam. Sometimes that will solve the problem.
Okay, okay.
ഷൈനി മിസ്സേ, ഞാൻ ഷീജയാണ്. നമുക്ക് ആർക്കും പ്രസന്റ് സ്ക്രീൻ ഓപ്ഷൻ വരുന്നില്ല മിസ്സേ. അതിന് അഡ്മിൻ എന്തെങ്കിലും ചെയ്യേണ്ടതാണോ?
ഷീജ,
നമുക്ക് പ്രസന്റ് സ്ക്രീനിലുള്ള ആ ഒരു ഓപ്ഷൻ കാണുന്നില്ല ഇതിലേ. അപ്പം അത് അഡ്മിൻ എന്തെങ്കിലും ചെയ്യേണ്ടതുണ്ടോന്ന് വരാനായിട്ടേ, സാറിന് പ്രസന്റ് ചെയ്യാനായിട്ട് അവിടുന്ന് എന്തെങ്കിലും ചെയ്യണോന്ന്.
ബെഞ്ചത്തെ കേൾക്കുന്നുണ്ടോ?
Madam, it's audible to me, madam.
It's audible. Audible, sir. ബെഞ്ചത്തെ എലിസബത്ത് ഉണ്ടോ അവിടെ?
മിസ്സേ, ഷീജ തന്നെയാണ്. ഇപ്പം പ്രസന്റ് ഓപ്ഷൻ ഉണ്ട് അവിടെ, ഇപ്പൊ കാണാം.
ഓക്കെ,
സാറ് നോക്കിക്കഴിഞ്ഞാൽ.
Lakshmana sir, is it already okay now? Can you hear me? Is it okay now? Hello? Hello? Hello, is it okay now? Hello? Is it okay? Now, I would like to introduce our first resource person for the K.R. Unni Memorial Lecture. Dr. Lakshmana Gomathi Nayagam is the head of the Department of Mathematics, National Institute of Technology, Trichy. He has 18 years of experience. He is a life member of the Kerala Mathematical Association. He did his PhD in Madurai Kamaraj University under the guidance of Dr. Venkatraman. And he has already published 50 research papers. And presently he is guiding a lot of research scholars. He has conducted 5 seminars and conferences. He has delivered almost 75 invited lectures all over the world, not only in India, but outside, abroad. And his specialization is in topology, but he will be talking on fuzzy numbers. And how many of you know that there is a fuzzy number in his name, Lakshmana fuzzy number? So he's the right person that we got, and a highly resourceful person. So on behalf of the Kerala Mathematical Association and on behalf of the St. George College, Arivithara, we extend you a very warm welcome to the first session, technical session of the conference. Dr. Lakshmana Gomathi Nayagam, please.
Good morning, sir. Is it audible, sir?
Yes, sir. Audible.
Okay. So now we will come to presentation. Okay.
So, have you heard the introduction?
Yeah. Now I hope my screen is visible to you. Am I right?
Yeah, that's okay. But just sir, has everyone listened to his introduction? What was told about him?
Yes.
So that
Yes
is
or
okay.
no?
Sir, that
Yes,
is
sir.
okay.
Okay. So over to Lakshmana Govindam Nayak sir. Now it is your turn.
Yeah, please, sir. Good morning, sir.
Okay.
Sir, I hope my screen is visible to you.
Yeah, that's right.
Right. Okay. First of all, I thank organizers, particularly Sunny sir and TT sir, right, who are the backbone of KMA. Okay. So really, it's my pleasure to join in this particular venture. Okay. So this conference is meant for recent trends in mathematics and statistics. Okay. So they have invited me to give lecture on this particular topic of similarity measure on fuzzy numbers. Okay, I am very happy. Okay, so since I have seen TT sir through screen, right? Of course, Sunny sir I used to see several times, and I used to talk to him over the phone and all. Okay, but seeing TT sir is immense pleasure to me. Okay. It's my fortune today I have, right? So with this, I will just enter to my talk. Okay, my talk is titled on similarity measure on fuzzy numbers. Okay, so this is the talk I am going to give. Okay, so right. So within this title, right, we are going to see first of all what do you mean by fuzzy number. So to know about fuzzy number, definitely it is required to see the term fuzzy logic. Okay, so the term it is taken from the imprecision. The fuzzy means it is a imprecision. Okay, it was coined by Lavoisier in 1965 for his theory of fuzzy sets and all. So to go inside the fuzzy logic, okay. So anyway, we start with the known from unknown, you know, right? So the known is binary logic, right? So we are all mathematician, right? So mathematics is nothing but study of logic, right? So everything it is formed or framed by means of binary logic till 1965. Okay. So in what do you mean by binary logic? Of course, everyone we know, right? So it deals with the statement or proposition, which is either true or false. Okay. So the truth value of the statement is either 1 or 0. Okay. So this is the base for studying the fuzzy logic and the further generalized logic and all. Okay. So Aristotle in 1930, in 300 BC, he developed binary logic. Okay, with the study of proposition, which is either true or false. Okay. Now you consider this statement. Okay, so consider this statement. I am a liar. This is a statement. I used to show this statement. Right. I start with this statement all the time. Okay. So what do you mean by the truth value for this particular statement? Okay. So this statement, it is an English statement. Of course, everyone we know, and we understand the meaning of this statement also. Then what about the truthness of this particular statement? That is the question we have. Right? Of course, can you tell about the truthness about this particular statement? So we usually think over, okay, either 1 or 0, because up to fuzzy logic or up to multi-value logic, so we have only binary logic, you know. So therefore, there is no other truth values for this statement I can think over. So only 1 or 0, right? So if it is 1, then automatically what it is implied, okay, so that we are going to see, right? So if the statement is true, that is the truth value is 1, then the statement is true, you know. Therefore, I am a liar, right? So I am a liar that I have told. Therefore, what I have told is also lie, right? Therefore, it will lead to I am not a liar. Okay. So if you start with 1, then that is ended up with 0. If you start up with 0, then it is ended up with 1. Okay, so this is the beauty of this particular statement. Okay, so this is the explanation for that. If the truth value is 1, then I am a liar. So what I am saying is lie, right? So I have told I am a liar, that is a lie. Therefore, I am not a liar. Therefore, it is ended up with 0. Right? So similarly, when you start with 0, then that is ended up with 1. Okay. So therefore, this type of statement cannot be studied by the binary logic. That was the conclusion, right? So based on the earlier discussion, right? So now you come to the further generalization of the particular two-value logic. Okay. So to overcome this difficulty, Lukaszewicz in 1930 defined multi-value logic. Okay. So he developed with multiple number of set of truths. Right. So between 0 and 1. Right. So he included 0 as well as 1. Okay. And he has given totally n value. Okay. So the state of truthness is given by 0, 1 by n minus 1, 2 by n minus 1, and n minus 1 by n minus 1. So on total we have, it is n state of truthness. Okay. So using this now, I can think over 3-value logic or 4-value logic or any number of n I can choose it. Okay. So after this invention, only the people they can study this type of statements. I am a liar. Right? So why it is required? Okay. Of course, to study this statement we have developed. Then what is the importance of this particular study? Okay, that is the important question we have. Right? Whenever we go for a new invention, it should be applied to real world, right? So then only it has own reputation, right? So you see, in the engineering applications, before inventing this multiple or multi-value logic, okay, the people they have invented the fan switches with either 0 or 1, right? Your grandfather and your parents may be knowing, right? So once the switch is on, then automatically, okay, this will flow, right? And if it is switch off, then it is switched off, right? So, but in winter, I want to have the fan with the slow speed, right? So then that type of importance or necessity only made this type of thinking of multiple logic and all, right? So now you see our regulator is made up of with 0, 1, 2, 3, 4, 5 with multiple 5 or 6 state of truth values, right? 0, 1, 2, 3, 4, 5. Therefore, 6 state of truthness is possible, based on which only nowadays the regulators have been made. Okay, but that is not my intention. I want to make a regulator with the possible movement of any direction. You think of it, right? I want to make a fan regulator, right, with the possible movement or possible direction. Right? How many direction we have? That is important. How many direction we have? Of course, everyone we think over, okay, 4 or 8 or the multiples, right? But in real number system, right, between 0 to 360 degree, we have infinitely many values, right? So of course, that is the mathematics we have, right? So between 0 to 360 degree, we have infinitely many values, right? So that type of direction I want to make it. Okay, therefore it should direct flow with any speed between 0 to 360 degree, right? So between 0 to 1, we have obviously infinitely many values, So that type of logic we want, okay? So that is the base for the study of this fuzzy logic and all, okay? So in another mathematical thinking of example, right? You think over the universe of discourse, the real numbers, right? And the predicate form of the closeness we are going to think over here. P of x is close to 0, right? So x is taken from real number system. That is our universe of discourse. Then you can ask again, can I apply the binary logic here, or can I apply the multiple logic here? Okay. If I would try to apply the multi-value logic, which is a generalization of the two-value logic, then automatically it includes the study of two-value logic. Therefore, I take this one. If I would try with this particular n-value logic, then what will happen? Right? Can it model this particular statement? That is the question we have. Right? So you see, x is a real number, x is close to 0, every real number is close to 0, right? Am I right? So every real number is close to 0, but the gradal value to be closed is different, right? So a baby can tell, okay, 1 is close to 0 because he may be knowing 0, 1, 2, 3 that way, right? A mathematician may tell, okay, so no, so every real number is close to 0. Am I right? So mathematicians obviously, okay, they are thinking that way only, right? So 0 is close to 0, right? Of course, it is completely true. 1 is close to 0, 0.5 is close to 0, 0.05 is close to 0, 0.005 is close to 0. Of course, 1000 is also close to 0, right? So it is depending on our subjective nature, right? Therefore, every real number is close to 0. Therefore, we want to tell some state of truthness for this particular predicate form with respect to x. Okay. But unfortunately, we have infinitely many real numbers. Therefore, this finite state of truthness is not possible to fix this problem. Okay. If I would tell, so this is our codomain set, So suppose I am going to use only these multiple values to fix any real number, then obviously infinitely many real number must be mapped to any of the numbers in A. Am I right? So for this, right? So infinitely many values of real numbers are close to 0 with the same Gödel value. It is meaningless, isn't it? Our mathematician never we accept. Okay. Of course, the applied people or some other engineer may think, okay, it can be, but a mathematician never we accept that type of scenario, right? So we want the infinite value logic to fix that type of problem, right? So this fuzzy logic fixes that type of problem. Okay. Now, so according to Zade, so we can think over the infinite value logic. So this gives the state of truthness between 0 to 1. Right? So 0 is also possible, 1 is also possible. So in between also it is possible. Right? So now I can make a fan, the regulator, with the possible direction, right? Between 0 to 360 degree, right? 360 degree may be taken as a 1, right? It is a normalized way, right? So 360, 0 to 360 may be mapped to 0 to 1, the interval. Okay, therefore, any direction is possible. Therefore, we can think over a regulator with the possible direction of any direction between 0 to 1. Okay. So this is the way we have. Right? This is the motivation for the development of Zade's logic or infinite value logic. Okay. It is of course fuzzy logic. Right. After his invention, so of course it is the study of continuous transitions. Therefore, obviously, this will be useful for the real-time problems where the continuities are there. Okay, so that is the idea behind this particular development. Okay, so once it is accepted, then this is the generalization of the Lukasiewicz logic. Of course, obviously, it is the generalization of the binary logic and other things. Okay, other things means Lukasiewicz logic. Okay, right. So according to him, so this is the function from the x to the universe of discourse to close interval 0, 1. Okay, so we usually call this function as the fuzzy subset of x. Okay, so of course it is the truth function when it is in the domain of logic. Okay, when it is in the domain of set theory, it is called the fuzzy subset. Okay, because the fuzzy subset is nothing but is a generalization of the characteristic function which deals with the membership layer in the binary or in the set theory. Right? Am I right? So using this setup, now we are going to think about the application of fuzzy logic. Okay, so for this, what are the things it is important, right? So the fuzzy proposition means, now you see it is a statement with some definite meaning having a truth value in 0, 1, the interval 0, 1, right? Therefore, any statement like I am a liar, right? Of course, there are something, okay, she is beautiful, Ram is clever, temperature is very high, and it is raining. Okay, so these are all different statements, of course, in English, right? Of course, you see, she is beautiful, right? So here the beautifulness, right? So the beauty, it is a qualitative nature, right? So it depends on the Gödel value. Right? We cannot tell, okay, whether she is beautiful or not, okay, depending on the subject. Okay, so subject, so who is evaluating, okay, that also it is important. So Ram is clever. Similarly, Ram is clever. Okay, it is whether it completely accepted or completely rejected, that we cannot. Right. So of course in the world nobody is completely clever, completely not clever, right? So everyone they have own intelligence, you know. So based on which we can fix the gradal value between 0 and 1. That is the idea behind this particular logic. Okay. Now you see temperature is very high. Right? So if it is given temperature is 20 degree, then of course it is accepted and we know the value of 20 and all. Right? But what do you mean by very high? How to model this? That is the question we have. Right? It is raining. Right? It is raining. What is the truth value for the statement? Whether it is raining, if it is raining, okay, we give a gradal value 1 or otherwise 0, right? So therefore, these type of statements can be studied after the development of the fuzzy logic, right? This is the base for the development, okay, right? Now, I want to go for the artificial regulator and artificial intelligence, right? That is our ultimate aim, you know, right? We want to do everything by means of the machine intelligence. Human intelligence is the best one, okay, but we are imitating our intelligence in the system because you see now in the COVID-19 scenario, right, the human cannot enter to the patient, right, but we are depending on the machine now, right. So in this type of scenario, we obviously need machine intelligence, right, whether it is better than human intelligence or not, okay. So it is definitely cannot be the replacement of the human intelligence, okay. So it imitates only human intelligence, okay, and it is useful in many scenario like this type of COVID scenario, right? So where the machine is important, right? So therefore, this type of modeling principle is very much important to study, okay? That is the idea, right? So already we have seen CRISP logic is the particular case of fuzzy logic, okay? So fuzzy logic, okay, it is the replacement. It can replace the CRISP logic, but CRISP logic cannot replace fuzzy logic, right? So already we have seen the example and all, okay? So therefore, obviously, I can replace CRISP logic by fuzzy logic. Therefore, I can study all the problems in which CRISP logic has been applied, okay? At the same time, there are n number of problems we have that can be applied only by means of fuzzy logic, and the CRISP logic cannot be applied, okay? So that is the beautifulness, right? So after the invention, okay, according to the founder author, Zade, okay, so his electrical machine got soft in nature, right? Of course, he invented for he's an electrical engineer, you know, right? He invented for his control problem, right? After this application of the fuzzy logic and all, okay, his machine got smoothness, okay. If you would apply this fuzzy logic in the railway system, then the train will go smoothly, right, without giving any jerk and problem, okay. So for this study is very much important. That is the motivation for us, okay. So finally, everything is a function, right? So we have a universe of discourse. There we are going to find out the function from that universe of discourse to close interval 0, 1. Therefore, it is the study of truth function or study of function. Okay, so that is the idea behind this. Okay, right. So it is the concept we have. Okay, so based on which we are going to develop the things. Right. Okay. Now I come to the modeling principle. Right. So we have just studied the fuzzy logic. Okay. So to model this scenario like very high, he is clever and all. Okay, we want some number system, right? So we without number system we cannot, right? Because already you see real is a set of real numbers, right? We want real application. These two terms real can of course be taken by means of this way only, right? So it is a real application and we want real number system, right? So without real number system or the generalization of the real number system or the imitation of the real number system, you call in any way, right? So we cannot do any application, right? So for this, okay, I am going for the fuzzy numbers, right? So the fuzzy numbers, it is the imitation of the number system, okay? So it is the imitation of the number system. So it is the truth function defined on the set of real numbers, right? So you can think over either as the imitation of the real numbers or generalization of the real numbers, whatever way you can think over, right? It is a function from the set of real numbers to the closed interval 0, 1, right? That is the thing we have, right? So based on which some properties it is taken from the real number system, and it is accepted as an axiom for our fuzzy number, right? So according to the existing definitions and theory, so A is normal, right? What is A is normal? So A is a function from R to 0, 1, right? So we know as a mathematician what is the meaning of function and all, okay? So this function, when it is called normal, that is a question we have, right? So if there exists x in the domain R such that A of x equal to 1, then it is normal, right? So of course we want imitation of the real number. Therefore, the set of real number must be the subclass of the collection of fuzzy numbers. That is our ultimate aim. Okay, because then only it is a generalization, right? So any set, any real number, it should be a fuzzy number, right? Therefore, we are going to take the properties of the real number and put it into the function from R to 0, 1, right? In the set of in the real number, singleton real number, we have that because at that point we have the truth value 1, right? Therefore, there is a point which has truth value 1. Therefore, the normality is there in the real number, right? The same thing it is taken, right? And each alpha cut is a closed interval, right? So alpha cut, it is again the making a subset from the function, right? So it is of course in our functionalities we used to tell, right, alpha cut, right? So by fixing the threshold value, right, we fix the subset, right? The set of all x, alpha is taken from the closed interval 0, 1, right? And set of all x in R is that A of x is greater than or equal to alpha is our alpha cut, okay? This alpha cut must be closed interval, right? And support of A is for bounded. So support means collection of all x in R is that A of x is strictly greater than 0. It should be bounded, right? So if you want, we can draw the picture, but I will just give lecture on this is the basic thing, then it will be boring for the people who are doing research and in their research level and all, right? So we just accept the fuzzy number. It is of the form, right? So if you want, I can draw here. All right. So so you see here, suppose I want to fix a real number. This is the real number. At this point, okay, so the Gradle value is given 1, right? And at other point, at other place it is 0, right? Therefore, this real number satisfies our requirement, right? Therefore, real number is a fuzzy number, and any fuzzy number of this form, okay? So we can think over this type of things are in triangular that way, right? So different types of fuzzy numbers are there. Now the alpha cut we are going to fix here, right? Alpha. Then the alpha cut is nothing but here we have, okay. So it is inverse image of alpha comma 1. Therefore, we have this way. This is our closed interval, right? So this is the way it is developed, right? So any fuzzy number of this form, right? It is a function from R to 0, 1, in which we have these 3 axioms that gives our fuzzy number, right? So then different types of fuzzy numbers are available in the real life, okay? Right. So now you see real number, already I have told, so our ultimate aim is generalization of the real number. Therefore, obviously real number is the subclass of this collection of fuzzy numbers. And intervals, of course, the second form of the imprecision is interval, right? Suppose I want to tell the truthness between some 40 to 50%, then obviously I want interval types, okay? If this interval types, it generalizes real numbers, right? And of course, it is the particular case of the collection of fuzzy numbers, right? And triangular fuzzy number, right? It is again one type of things, right? It is of the form triangle, right? Suppose I want to make it around A, right? Then I can use this triangle fuzzy number, right? Trapezoidal fuzzy number, it is another type of fuzzy number in which I can think over this type of things, right? So here around A to B, I can model by means of this trapezoidal fuzzy number, and pentagonal fuzzy numbers are there. and hexagonal fuzzy numbers are there. Okay, so these are all again piecewise linear shapes of fuzzy numbers. Okay, so where it is useful, of course, it is useful from when we use the non-linearization to the linearization, right? So of course, in real life, all the problems are meant for non-linear concepts. Okay, but when you use the non-linearity, then the solving problems may be little difficult. Okay, so to make it the non-linear to linear, we are using different approximation methods. When we use approximation method, then so this function, right? So I can approximate by means of triangle, right? Then obviously I am losing this information, right? So if I would lose this information, then it is not giving the accuracy, you know, right? Therefore, we want the other type of pentagonal and hexagonal, right? When I use a hexagonal, you see this type of things will come, right? So therefore, this will give you, right? So pentagonal shape of fuzzy numbers. Of course, it is the approximated form of linear, non-linear, parabolic or general bell-shaped curve. Okay, but with the loss is less, right? So here only this type of loss we have, right? Therefore, so when we go for approximation, right? So this hexagonal, pentagonal are the replacement for trapezoid and triangular. That is the idea, right? And the parabolic fuzzy number, it is the non-linear fuzzy number, and of course quadratic fuzzy number and generalized fuzzy numbers. Different shapes, different types of fuzzy numbers are there. Based on the application, the researcher, they can use their own set of fuzzy numbers. Okay, so that is the idea, right? Right. So once we have fuzzy number, then obviously the different operations are there. So this is another area of research where lots of research is going on, right? So fuzzy number, it was invented in the year of 1974, right? After which many operations they have defined, right? Since the new notions like pentagonal and hexagonal and all, there are many the research is required to fix these operations and all, right? Because when we apply these hexagonal fuzzy numbers, then obviously in the decision modeling or in the control theory, so we want the foundations for these hexagonal fuzzy numbers and the pentagonal fuzzy numbers and all, right? Therefore, so this is the area in which lots of research is already done. Okay, it is all going on also, right? So that type of things here, right? So intersection, union, complement, and addition, multiplication, fuzzy minimum, fuzzy maximum. These are the different operations we have. Okay. Right. So now, when we think over the operation, so this is one of the important principle we have. It is the ranking, right? So ranking is important. Why? Because it is the application. It has application in the MCDM or multi-criteria decision making and all, right? So that means when we think over the decision making, right, the decision is depending on optimum, you know. Then what do you mean by optimum, right? Optimum, it is obviously depending on the some relation, right? The relation is nothing but our usual ordering principle, right, in the set of real numbers. Therefore, there we want, so this study of ranking fuzzy numbers and all, right? So when we think of a ranking of fuzzy numbers, then obviously, right, so it should have some axioms, right? Because it is containing the set of real numbers, right? And it contains the set of intervals. Therefore, whenever we go for a new principle of ranking, then that ranking must satisfy or validated in the set of real numbers and interval numbers. Okay, so that is the thing we have. So this is the axiom we have, right? Of course, we want the total ordering principle, right? So that is the second principle we have, right? So these two axioms we are going to fix it, based on which the research is going on the ranking of fuzzy numbers, right? So the first type, so this is the ranking principle available in the literature, right? So A subset of B, A and B are two fuzzy numbers. Then this mu A and mu B are two fuzzy membership function. It is attached with A and B. That is mu A is a function from R20, 1 and mu B is a function from R20, 1. Okay. So these two functions can be compared based on mu a of x is less than or equal to mu b of x for every x, right? Because mu a of x is lying between 0 to 1 only, you know, right? Because it's a function from r to 0, 1, right? Therefore, mu a of x is a number from 0, 1, and mu b of x is a number from 0, 1. Therefore, there we have already Euclidean ordering principle, right? Usual ordering principle. So based on which you can compare, right? So this is the first ordering principle available in the literature. But unfortunately, this will not satisfy our requirement. Unfortunately, it does not satisfy the first requirement or the first axiom, right? The first axiom is what? The validation in the set of real numbers, right? When you take two real numbers, right, here A, it is A, and another one B we have, right? So these A and B, two real numbers, cannot be ranked, right, by means of this principle. Because A is A, it is attached with this function, right, this function, and this B, it is attached with this function, right? Then obviously, depending on the domain value, right, we have mu A of x is less than mu B of x, or mu A of x is greater than mu B of x with respect to the domain point A and B and all, right? Therefore, I cannot apply this definition for comparing even two real numbers, right? Therefore, it is not validated in the result of real numbers. Okay, right. Now, I want to again update this things one, you know, right? So that is the thing the people they are doing, right? So the first form of ranking principle is done by Wang, right? So he has done in his theory based on the centroid. Okay, so he is going to fix the centroid. Of course, we are the mathematicians, so definitely we have, right? So this is the fuzzy number you assume, right? Then we are going to fix x0 and y0, the centroid, right? This x0 and y0 can be found using this integral formula, right? We are the authority for integration, you know, right? So this integral formula we have applied in UG level itself, right? So whenever we are given some polygon, then from the polygon how to find centroid, this is the formula we have, right? So minus infinity, infinity, because the domain, the function is defined from R, right? But it is only bounded in nature. Therefore, this minus infinity to infinity can be modified to this end point, right? It may be A, and this point may be, right? It is A, and this point may be B. Therefore, here I can make it A to B, will not affect our theory, right? So therefore, using our centroid, right? Now I can fix a centroid distance, right? So this is again a finding of y coordinate. Okay. So of course, this GR is nothing but the inverse image, inverse function for the function m, the membership function. Okay. So that is the way we have. Right. So using this, we can fix the centroid x0, y0. Then you go for the distance here. Right. This distance is nothing but the distance between origin and the centroid. Okay. It is a real number. Right. So of course we know how to find the formula and all. Right. Root of x0 minus 0 whole square plus y0 minus 0 whole square, is nothing but root of x0 square plus y0 square. Okay, so that is the thing we have. So now when you think over a triangle here, right, then the triangle, it is having the endpoints with here a comma 0, right, and here b comma 1, and this is 0 comma c comma 0, right. Therefore, when you think over this triangle, then what is the centroid? Of course we know, so it is nothing but a plus b plus c divided by 3, and this y0, that is equal to 1 by 3, because it is 0, 1 and 0, right? The summation. Of course, we know x1, y1, x2, y2, x3, y3. If they are the vertices of the triangle, then obviously x1 plus y1 plus z1 divided by 3, comma x2 plus y2 plus z2 divided by 3. That is our centroid, right? That is the thing here. Right? Of course, here y1, y2, y3 are nothing. Sorry, y1, y2, y3 are nothing but here 0, 1, and 0. Therefore, it is 1 by 3. Right? So, using this centroid is found. Then the distance we are going to find here again. Okay, this is our centroid distance. Then it is a real number. So therefore, we are attaching a real number to this function, the triangle. So then we can compare any two triangle by means of our Euclidean or usual ordering principle. That is the idea here. Okay, right. So this now whether it satisfies our requirement, that is the question, right? Whenever we go for a new definition, we have to verify whether we have done it or not. Okay. So this is the definition we have, right? Whenever we are given with two triangle or two trapezoidal valued function, then corresponding to them, right? Corresponding to them, we are fixing the centroid scores, right? The centroid scores, okay, we are going to compare, right? So it should satisfy for at least real numbers. That is our requirement, right? Whenever we are given two real number, then the scores must be compared with the same ordering, right? If you have A less than B, then here also I have to get A less than B. It is possible, okay, right? So this is the ranking and all we are talking, right? So then so some more theories are there, okay? So I skip here due to the time constraint and all, okay? I come to the next topic, okay? So this is the topic in the ranking of fuzzy numbers, right? So when we talk about fuzzy numbers, so we cannot miss this topic because this is having lots of application and research in the whole domain of research, okay? Now we come to the next domain, right? The next domain is, right, introduction of the similarity measure. This is the topic we are given, right? Similarity measure on fuzzy numbers. That is a topic, right? So already we know about fuzzy numbers, right? So then similarity measure where we are going to use without motivation, why we are going to study? That is the question we have, right? Of course, obvious, right? So without motivation, nobody will study anything, right? So I want the motivation for this one, right? Now the similarity, what it is dealing with that we will first of all see, right? So this similarity is very much useful here. This is the definition, right? So similarity is nothing but the study of again function, right? So suppose we are given, so you just take today sub-collector sir has talked about COVID and all, right? Now in India you see near about 20 lakhs patients are there. Of course now maybe it is lesser because it is a total count. It is a total count, but really who are under treatment, it is near about 2 lakhs. You just assume, right? What are the parameters it involved in the COVID? Okay, that is the question, right? The doctors and researchers, they want to fix the symptoms. The parameters is nothing but symptoms, right? The symptoms of the COVID we want to study. How to find out the symptoms? We have 2 lakhs patients, right? It is COVID positive patients are there, right? From each one, they have their own different symptoms, right? Of course, some people, not some, okay? Many of them are without symptom also, right? Am I right? So among the 2 lakhs, we have, that is the data point. From the data point, we are going to fix the parameters. Now, to fix the parameter, right? So each one they have the different parameters, some parameters with different grades and all, right? So we have to fix them, or we have to cluster them, right? So we have to group them, right? So how to group them? Again, it is depending on the some measure, that measure is nothing but similarity measure, right? How these 2 patients are similar with respect to these symptoms, right? So that only we are going to study, right? So the clustering the patients is nothing but, so we are grouping the patients with respect to symptoms, right? So grouping the patients with respect to symptoms, it requires some measure, right? How much symptom he is having, right? Everyone, they may have cough and fever, right? So then what level or what grade they have, okay? So for students or for the youngsters, right? What would be the gradal value? For the patients of aged 60 and above, what would be the symptoms and what gradal level it is about the symptoms, okay? So for each and everything now, we want to measure those symptoms and we are going to measure the data point, the patient 1 to patient 2 based on the parameters, okay? So for this type of relation is important, okay? So whenever we have this function, it is a function from universe of discourse cross universe of discourse x cross x to close interval 0,1, right? It is said to be similarity relation. When 2 data point is similar, when 2 data points are similar, obviously x and x both are similar. Am I right? If you have 2 patients two different patients, then you can think over the similarity maybe less than 1 or it may be 0 also. Right? If two data point or the patients remain same, right? For two identical patient, right? Then what would be the similarity relation? Obviously, it is expected 1 only, you know, right? All the parameters are remaining same, right? With the same Gretel value also. Therefore, so we want, right, that type of the measure is ended up with 1, right? So therefore, so we are defining the function. It is a function from the patient cross patient when we talk about the COVID, right? So generally, as a mathematician, we have x cross x. It is a general structure we have, right? Then it is a function from x cross x to closed level 0, 1, right? Of course, obviously, we have some mathematical knowledge, right, based on which, so the Gretel, the similarity measure, it never goes beyond 0, right? Therefore, it lies between 0 and 1, right? If they are totally negating the other, then we can think over 0. For example, so in the set of x equal to 0, 1, right? Then 0 and 1, right? 0, 1 cross 0, 1, we are going to talk about. Then there, 0 and 1, obviously they are two different entity with the maximum distance. Therefore, I can think over the similarity 0 there, right? Right? So for 1, 1, I can think over obviously 1 only, right? For any real number that way. So we are having this function which is defined from x cross x to 0, 1, right? With this 0 and 1, right? It is included, and in between also, right? So this is the first one we have, right? So this is a important thing I have, okay? Right? So 0 less than or equal to s of x, y less than or equal to 1, right? The second one you see x equal to y. Whenever the patients are identical, then the Gretel value of k is same, and the similarity is also it is same, right? That is the expectation, you know. Therefore, this is also assumed as an axiom or property. Then, whenever you have the similarity between two patients x1 and x2 or x and y, then obviously the similarity between y and x also it is expected same, right? Therefore, we are thinking of this type of property, right? S of x, y, that is equal to s of y, x, because similarity between x and y and x remains same, right? Therefore, we are assuming this property, right? And the another one you see, it is an important thing, okay? It replaces whenever you have x, y is a tree patient, x and y are having similarity in nature with some Gretel value, that is s of x, y, and y and z has some Gretel value, s of y, z. Then it is expected to have the Gretel value for x and z must be greater than or equal to supremum of minimum of this s of x, y and s of y, z for any x, y, z. Okay, so we are talking about the similarity nature between x and z, right? So then we have to find the similar measure for every y in the set with the x and y and z. Based on this, you are going to take minimum, and of course with respect to y, right? So the supreme is taken on y. So based on which we are having some real number. So we have the Gretel value must be greater than or equal to the supremum. Okay. So this is our assumption, right? If you assume these all four property in a function with whose domain is x cross x to 0, 1 as a codomain, then we call that a similarity relation. Okay. Now, when you think over this as a similarity relation, okay, so is there any replacement, right? So of course it is the generalization of the equivalence relation only, right? So you just think over, so it is nothing but our equivalence relation. In the equivalence relation, we have this structure, right? So whenever we define equivalence relation on any set x, then it is a function from x cross x to the 0, 1 with again the properties of all four. It is accepted, right? Is it okay? So therefore, so this one, the similarity relation is the generalization of the equivalence relation. Okay, that is the idea behind this particular one. Okay, right. When we have similarity relation, it is equal to say, okay, already we have seen, you know, the similarity grade between 0 and 1, it is expected 0, right? And but the distance is, you know, right? Distance between what is 0 and 1? It is 1, right? Therefore, the distance is 1, but similarity is 0. So by means of this example, I can understand, okay, there is a relation between the similarity and the distance function, right? So if you have a huge distance, then obviously the similarity is less, right? If your distance is very close, then obviously similarity is more, right? That is why if the two patients or two data points are identical, that means there is no distance between them, right? That is, the distance is 0. When you have distance is 0, then obviously the similarity is 1. Okay, so therefore there is 1-1 correspondence with this particular similarity and our distance function. Okay, of course we are the authority for metric, you know, right? So from our UG itself, we are studying the metric, right? It is a concept of distance function, right? So in the distance function, we are having this type of properties and all, right? So it is again the generalization of the Euclidean distance. Okay, so d of x cross x to R with these properties. Obviously, we accept the non-negativity. The distance between any two data point must be greater than or equal to 0, right? And obviously, if it is identical data point, then it is expected distance is 0, right? In both way. And d of x comma y equal to d of y comma x. It is for symmetric in nature. Of course, we know, right? So this is the definition of this particular metric, okay, or distance function, right? We are the authority, right? This fourth one is our triangle inequality, right? But when you think of a triangle inequality, these three are, of course, having a 1-1 correspondence with the earlier one. Okay, here you see all the things are greater than 0, and you can think of a, right? There is some correspondence. That is 1 minus of the distance. Maybe it is taken as the replacement for yes. Okay, so because already we have it, right? So for 1 comma 1, the distance is 0 and the similarity is 1. And for 0 comma 1, the distance is 1, the similarity is 0, right? Therefore, 1 minus of distance is nothing but our similarity relation. That is the idea, right? Now, whenever I have a metric, right? So for each metric, I can think over one similarity relation, right? But unfortunately or fortunately, there is a point of study, right? So if everything remains same, then of course there is nothing to go for further, you know, right? My teacher and of course Sunny sir and Trivikram sir, they definitely several times they have told, right? If the property is not valid, then the mathematicians are happy, right? That means we are having an enormous role to work it, right? If it is satisfied, there is nothing to do it. Okay. So if it is not satisfied, then only we people to make what condition, on what conditions it is satisfied. For this enormous work and research we do it. Okay. So whenever it is not obeying or it is not validating, so of course as a mathematician we are happy, right? So this fourth one will not give the fourth one of this particular similarity relation, right? Here we want s of x z is greater than or equal to supremum minimum of that one, right? And here it is a triangle inequality, right? Am I right? So this will not give that particular one, right? And that particular one will not give this particular triangle inequality. Okay. Therefore, so they are thinking of one more stronger version of the metric that is called ultrametric. Right? In the ultrametric, so it is a metric along with this one d of x comma z less than or equal to infimum of maximum of d of x comma y, d of y comma z for every x comma y comma z. Right? When you think about this ultrametric, then this 1 minus of d, right? 1 minus of d will give 1 minus of infimum. 1 minus of infimum, in real analysis, you know, 1 minus of infimum is nothing but, right, supremum of 1 minus of the maximum, right? So when you think about 1 minus of here, this 1 minus of infimum is nothing but supremum of 1 minus of maximum. This 1 minus of maximum is nothing but minimum of that. Okay, so minimum of 1 minus d and 1 minus d. Therefore, I can travel from this ultrametric to this particular one. Am I right? So here I want supremum and there is nothing but supremum and minimum. Here you see here it is infimum and maximum, right? So when you put 1 minus the complement we are talking, right? 1 minus in fuzzy mathematics is nothing but it is complement, right? 1 minus d or negation in the logic, right? So when we think over the ultrametric, the negation of this ultrametric is nothing but the similarity relation. Right? Therefore, when we talk about the similarity measure and similarity relation, as a mathematician, what I can think over, just I can define one ultrametric. Okay, that is the way. Here, lots of research is going on, right? So on fuzzy numbers, how to define the ultrametric or distance between the fuzzy numbers, right? Whenever we have distance between fuzzy numbers, from which I can travel to the similarity measure between fuzzy numbers. Okay, so that is the idea. Right? Therefore, so here we are authority from which we can move to the similarity measure, right? I usually travel from the known to unknown, right? So this is the known concept. Several times we have applied in our UG and PG curriculum, right? So you take it any distance function, see, or any C infinity, right? Whatever the function you take it, right? Any distance metric you take it, right? Based on which I can go to the similarity measure. That is the idea, right? Now you see, it is one more thing. So this is usually applied in the image processing and all, right? The translation invariantness, right? So of the translation invariant, from the name itself, you understand, okay, what type of metric it is. It is a metric, right? Any metric, it gives some topology, right? That is nothing but metric topology. From the metric topology, we can talk about the translation invariantness. That means when I move a geometric figure from one place to another, the property will not be changed. That is called translation invariant. Am I right? Right? So the property which is preserved by the translation is called a translation invariant. Right? That translation invariant property is maintained by this metric, translation invariant metric. Okay. So therefore, when you define the metric with this property, then it is called a translation invariant metric. This is useful in our image processing and all. Right? When I want to make, suppose I have some figure here that should be transformed to this place without changing its property, then I can use this particular translation invariant metric. Okay. That is the idea, right? Just I am replacing or translation I am giving here, right? Of course, I here not only translation, I have given some, it is stringing and extraction is done, you know. Therefore, that also it is right. So, using the geometric study, I can think over this translation invariant and all, right? So here, lots of research is going on. Okay. Right. So again, you just map these two, right? Distance and similarity measure. So similarity measure is nothing but again defined on fuzzy numbers we are talking here, right? So instead of taking any universe offset, we are going to talk about here fuzzy numbers, right? Therefore, here it is a function from the collection of fuzzy numbers cross collection of fuzzy numbers to 0, 1. That means what? Whenever I am given with two fuzzy numbers, then I am going to give some Gödel value with respect to that particular shape and what are the parameters it is involved. Okay. So in the fuzzy numbers, what are the parameters it is involved? The bounds are involved. The shape is involved. Okay. So the deepness is involved. Okay. So based on which you can think over different Gödel value, right? Am I right? So for the same triangle, right? If the same triangle is taken, then only the Gödel value is 1, right? If I will take, of course, what I have drawn two different triangle as a mathematically, right? Because there is a difference we have, right? Therefore, obviously, there is a information loss between these two, right? Based on which we are going to fix the Gödel value, right? So this function is defined based on the parameters it is involved in the fuzzy number, right? So it is a function from f of r cross f of r. For any two fuzzy number, we are giving Gödel value with the property. Again, it is a imitation of the fuzzy relation properties. Okay. A, B, C are domain point here taken as fuzzy numbers. That's all. Okay. So when we think about this similarity measure, right, this will be very much useful. I already have told it is nothing but the fuzzy equivalence relation, right? It is a generalization of the equivalence relation. So equivalence relation is useful for studying the partitioning data and all, right? Of course, grouping and all, right? So then obviously this clustering and the pattern recognition and all, it is possible to study, right? So pattern recognition is nothing but it is again study of application of the similarity measure only, right? So we are studying, suppose we are having different patterns, right? The patterns are given. A new data point is entering. Right? This data point has different parameter, right? And we are going to compare this data point with this particular center head of the cluster. Okay, it may be here. Then using this similarity measure, you are going to think over whether he is belonging to this pattern or this pattern. Okay. Of course, you see again the COVID-19 scenario, right? So of course, 2 lakhs data points are there. So based on the characteristics and symptoms, we are clustering them. Different clusters are there. The 2 lakh may be reduced to 100 or 50, right? After making 50 clusters, a new patient is coming, right? That new patient, where he is going to get a seat in the particular cluster, right? So again, it is depending on the characterization on the particular patient. Okay, what type of symptoms he has, what is his age? Age is again parameter, and of course if you want, you can think over, right, color, right? So UK and Indian, they have different characteristics, you know, right? Therefore, even color you can make use of it, right? Gender you can make use of it. These are all different parameters. And of course, cough and throat sore, and of course lung infection, right? So the different parameters, what are the things medically, it is all there, that you can take it as a symptoms here, and we are going to measure them, and we are going to compare them based on the similar nature, based on which we are going to put him as in this particular cluster or in this particular cluster. Okay. Therefore, the pattern recognition and of course this clustering are having enormous role in the computer science research, and of course in the data science and all, right? So for this, okay, so this is the tool, right? The similarity measure is one of the tool for studying those things and all. So when you think about this similarity measure, okay, so where and all it is useful, that we are going to see again, okay, and some more particular discussion on the generalized fuzzy number also we are going to see, right? So what do you mean by again generalized fuzzy numbers? That is a question we have, right? So in fuzzy numbers, we have already similarity measure. Here again in the generalized fuzzy number, we are going to see fuzzy number, similarity nature, right? So for this, we are going to think over, so this type of A, B, C, D, W, what is W here? That is a question we have, right? So I come to again the definition of the, right? So we have triangular fuzzy number you accept here, right, with the Gödel value. So this is our Gödel value 1. Suppose I fix W less than 1, right? W less than 1, then we can fix over triangular fuzzy number of this form. Okay. So this triangular fuzzy number, it involves with the endpoints A, of course B comma B. It's a triangle, you know, therefore B and C are same, right? A comma B comma B comma then D, right? So these are the bounds, and this W is nothing but the height. Okay. Therefore, the generalized fuzzy number is having this type of definition, right? It is a function which is defined from R again, but if the closed interval 0, 1 is replaced by 0, W, where W is less than or equal to 1, right? So in the fuzzy number, we are making W equal to 1, and all other properties are accepted. Okay. And here we are making the generalized version. So why this is required, you know, in some engineering application and in our decision sciences, it is required, right? For example, suppose I am telling, okay, the normal, the pressure level, right? The pressure level is normal if it is 90 and 120, right? So if it is told, then you can think over, no, so the 90 and 120, right? It is not exactly, we cannot fix it, okay? So it may be with a lesser than that 90, 89, okay? The Gödel value may be lesser than 1, okay? So that may be taken normal, right? So that type of scenario may be fixed by the generalized fuzzy number, right? That means the information is characterized with the partial truthness, right? Suppose I am telling my salary is 70,000 or around 70,000. Around 70,000 is making fuzzy number, right? Around 70,000 is partially true, I am telling, or it is 60% true, I am telling. Okay, then that 60% here I can make it with 0,6, right? Therefore, if the fuzzy number, the information about the fuzzy number, if it is partial or otherwise, okay, it is some number less than 1, then I can think over the generalized fuzzy number, right? Therefore, it is a function from again R to close interval 0,1, right? So with the, of course, I have assumed continuous, but usually for generalized version, it is not required. Okay, but in engineering application and in our real-time applications, we are using the continuous assumption, right? Because our real problems are continuous transient ones. Okay, therefore I can assume this continuous function from R to close interval 0, W, and mu a of x equal to 0 whenever minus infinity to a, right? So you know, right? So that is my a, and of course b we have, and c, and of course it goes there d and all. Oh, sorry. Right, so we have this way a, b, c, and d, right? Then I can fix here w, and I can fix here this function, right? But minus infinity to 0, a it is 0 only, you know, so that is fixed. And similarly d to infinity is again 0, it is fixed, right? And between b and c it is w, it is again taken, okay? And you see strictly decreasing, it is assumed here, and it is strictly increasing and it is strictly decreasing. Okay, so these are the parameters it is involved in the fuzzy number. It is very much important, right? So the parameters only it is useful for developing the similarity definition. Okay, therefore everything is important here. Okay, right? So in the generalized fuzzy number, right? So these A, B, C, D are of course our foods, and A and D are called left and right food. Okay, and of course B, C, it is nothing but the core, right? And our W is our the height. Okay. Right. Now, so this is called a trapezoidal fuzzy number. Again, what I have drawn in the last slide, that is a trapezoidal fuzzy number only, right? Only at this point it is W, right? If it is 1, it is a trapezoidal fuzzy number, right? So therefore, here this is a trapezoidal fuzzy number. It is around BC, the interval B, C, around B, C, right? With the truthness of W. You assume that type of real application, right? The expert, whenever we go for the data collection, at that time we can find this type of scenario, right? When we talk about the symptoms to the doctor, then the doctor may tell, okay, the symptom is one of the characteristic for this particular COVID. Okay, so then we ask, is it completely correct, sir? Then they may think over, or they may change their stand with the no, this may be 90% is correct, or 60% correct, that way, right? Then in that scenario, I can fix this generalized trapezoidal fuzzy number for my application. That is the idea here. Okay, so if you are very certain, right, then this W may be taken, then it is nothing but our trapezoidal fuzzy number, right? So that is the scenario, right? So this trapezoidal fuzzy number, generalized trapezoidal fuzzy number, is generalization of the trapezoidal fuzzy number, right? And of course, you know, B equal to C, then it is triangular in nature. And of course, when you take A equal to B and C equal to D, then it is again nothing but our crisp interval. And if all are equal, then it is nothing but real number, right? Therefore, the generalized trapezoidal fuzzy number, it is a generalization of all those concepts. Okay, that is the idea. Right. Now, I have taken one definition, similarity measure, defined on this particular generalized fuzzy number. It is defined in the literature 15, right? So based on which we are going to discuss, right? So he has taken two similar generalized fuzzy numbers, A and B, with A1, A2, A3, A4, WA, right? And B1, B2, B3, B4, WB, right? So two generalized fuzzy numbers. And of course, here you assume A1, A2, A3, A4 all lies between 0 and 1, right? Usually in the fuzzy number we don't, but in the normalized sense, I can make it, right? any fuzzy number, I can map it to fuzzy number within lies in 0, 1, right? Just I have to normalize. As I have told, 360 degree may be taken as 1 by normalization. Similarly here, any number, right, whose endpoint is any real number A can be made it into 1 by means of the normalization, right? Therefore, I have assumed the foods are lying between 0 and 1 here, okay, right? If not, I have assumed it is V and Shen they have assumed, okay, right? So according to them, right, so they have developed one similarity measure, right? So this is the similarity measure according to them, okay? How it is defined? This A and B, it is taken 2 fuzzy numbers, right? So for these 2 fuzzy numbers, generalized fuzzy numbers, this is the definition, right? So 1 minus sigma A modulus AI minus BI divided by 4 here, right? And they are multiplied with minimum of P of A, P of B plus minimum of WA, WB divided by maximum of P of A. You see, right? This is the definition. This is the definition given by V and Chen. Okay. So, what is P of A and P of B? Already I have told, right? So this fuzzy number, it depends on different characteristics. One is okay, same, right? Now, for only if I would use only endpoints A and BI, right? Then for any endpoints AI, BI, any generalized fuzzy number, I have same gradal value, right? Am I right or not? Okay. If I have a fuzzy number of this type and sorry, here you assume, okay, so both all the 3 it is passing through 3 endpoints, okay. Now you see the shape only it is different, okay. The endpoints remain same, right? If I would use only this part, then this will give the same similarity nature for all the things with the same endpoints or same vertices, okay. So he has thought of the shape. Depending on the shape only he is going to think over, right? The shape is depending on the perimeter, Therefore, he is taking P of A and P of B are perimeters, right? So one of the characteristics on the fuzzy number is the shape, based on which he is talking about the perimeter of the particular fuzzy number, right? So now for this fuzzy number, I have one, right? So for this one, I have one type of shape, perimeter, and for this another perimeter, but the endpoints remain same, right? Therefore, even endpoints are same, okay, depending on the perimeter, the similarity nature is different, okay, that is the idea, right? Idea of course, V and Chen, right? Okay. Then, based on which, of course, this perimeter only it is written here, right? Mathematically, it is written, right? So, A1 minus A2 whole squared plus WA, right? It is A whole squared, okay? And of course, root of A3 minus A4 whole squared plus W A squared, right? This is the perimeter of P of A, right? So this perimeter is taken here, and minimum of the perimeter, and of course WA and WB, they are the heights. That is again other characteristics of A and B. Therefore, that is also taken here. The endpoints are taken. All the characteristics almost is taken, based on which this definition is made. Okay. So maximum here it is maximum of P of A, P of B, and of course it is again normalization, right? So we want S of AB between 0 and 1, Therefore, minimum plus minimum divided by maximum, it is normalization to make it between 0 and 1. Okay. So this S of AB is defined like this, right? Now, whether it satisfies our requirement, of course, it satisfies our requirement. Okay. So satisfies our requirements what? It satisfies the non-negativity, that is S of A lies between 0 and 1. Okay. By the definition, you can see it is always greater than or equal to 0, because it is positive, it is again positive. Okay. Therefore, it is greater than or equal to 0. Of course, it is less than or equal to 1 because we have normalized everything. Okay. Of course, here it may be a maximum of 4, that is why it is divided by 4, right? Therefore, it is less than 1. 1 minus of that, it is again less than 1. It is again less than 1. Totally, it is multiplied again less than 1. Therefore, it lies between 0 and 1. In the same way, you can verify all the parameters required for our S of AB, the similarity relation or similarity measure. Okay. So see, S of AB between 0, 1, the first property is verified. The larger the value of S of AB, the greater the similarity. That is the thing. Of course, we know, right? if S of AB equal to 1, then A and B are almost similar, right? They are the similar. Of course, they are identical according to our expectation. But in theory, okay, we have not assumed. If A equal to B, then only it is S of AB equal to 1, right? The converse is not assumed in the definition, right? Therefore, you can have S of AB equal to 1 with a different A comma B. That is possible, right? The identicality may not be required, okay? So, we can think over the properties and the validation and all, okay? That is B.N. Chen, his definition, right? Now, it is a small limitation. Whenever we think about the research, right, from the existing, how we can modify, right? So that is our requirement, you know, right? If it is understood to you, then anyone you can work on and do research, right? So this is our existing definition. So here we are going to change a small change by which we are going to get better research, right? Or the different research. Okay, that is the ultimate gain, right? So it involves with the perimeter and okay, the height and the endpoints. Okay, so these are the parameters. The same parameters are only it is also in the novel similarity measure if we are going to take. Okay, so A, B, C, D, and W it is taken, right? And say again the perimeter. Instead of taking perimeter, you see here P of A, small definition it is changed, not more than, right? And here instead of putting 1 minus sigma, it is taken product of 1 minus of A minus B. You see in the earlier definition, you see, so in the earlier definition, right? So what is this? Sigma modulus A minus BI divided by 4. You multiply 4 here, then 4 minus of this. The 4 may be separated 1 minus and all. Therefore, 1 minus modulus A1 minus B1 plus 1 minus modulus A2 minus B2 plus 1 minus A. That is the thing, you know. That's average only you are going to take. Am I right? So the 1 minus of sigma modulus A minus BI by 4 is nothing but the average of 1 minus of modulus A1 minus B1, comma 1 minus of modulus A2 minus B2, comma 4 endpoints, right? 1 minus A4 minus B4 modulus, right? It's average only it is taken here, right? Of course, in mathematics, what is the replacement for average? Average is taken here, right? Of course, I don't want to use his own principle. I want to differentiate or distinguish my definition. What is our replacement of the average? It is nothing but geometric, you know, right? So average arithmetic mean is nothing but it is replaced by geometric mean in some sense, right? Whenever we have arithmetic mean, right, average files, then we think over geometric mean, right? Then I have used here just geometric mean. You see how the research is done just by modifying a smaller and smaller thing, right? So the arithmetic mean I don't want to use it here. I have done it here by means of the geometric mean, right? 1 minus A1 minus B1, 1 minus A2 minus B2, 1 minus A3 minus B3, 1 minus A4 minus B4. The same 4 elements I have taken. B and Chen, they have taken arithmetic mean. I have taken here only geometric mean. That's all, right? Am I right? So the same way here you see P of A, he has taken the perimeter. When we think over the perimeter, right? So I can draw the things. Okay. So when you think over the perimeter, so this distance is twice added, right? So this distance is added here. A3 minus A2 is taken, and this distance and this distance, that totally he is going to count that way, right? So in this perimeter, instead of perimeter, when you use this definition, right? What it is? So A2 minus A1 whole squared, A3 minus A2 whole squared, and A4 minus A3 whole squared, and WA whole squared, right? It is not defining the perimeter, right? It is some other value, right? P of A, it is not a perimeter here, right? So, but it is a replacement for the perimeter in the earlier definition, right? So, based on which we are having one more structure. Now I have two structure based on which I am going to multiply as in the earlier, based on which we are going to have one relation. This S of AB, now we are going to verify whether it satisfies our similar relation or not. Okay. Now whether it is lies between 0 and 1. Of course, they are all non-negative numbers. It's a distance only, right? Root of the things. Of course, positive root we are talking. All are real numbers. Obviously, right? There is a positive square, sum of the squares at the same time. Therefore, it is all positive, right? Therefore, it is normalized also. Therefore, it is less than 1. Of course, here it is 1 minus of this, it is less than 1. The geometric mean again, it is, we are talking the product and its root. Again, it is less than 1. Totally, it is multiplication less than 1. Of course, it is greater than or equal to 0, right? Therefore, it lies between 0 and 1, right? Here, one important thing is this property is also valid. That is important, right? In the last definition also, it is valid. Sorry, that was not told, right? So this is also valid. That means, sorry. So the identicality here, right? If and only if S of A comma B equal to 1, right? This definition, similarity measure, of course, not only the similarity measure, the V and Chen also satisfies, okay? So this is a stronger version than the similarity relation actually, right? It is expected, you know, so whenever I have the similarity remains same, then those two objects must be same, right? That is my requirement, right? So for this, so this will be very much useful, right? So the property 1, it lies between 0 and 1, it is also, it is satisfying, okay? Right? The second one, the identicality is also, it is satisfied, okay? For A equal to B, you can verify S of AB equal to 1, right? Because this is the definition, A equal to B means obviously it is 0, therefore it is 1. So A equal to B means the minimum and maximum remain same, therefore, okay, A equal to B means WA again will come. Of course, it is 1, right? It is easy. But when you think over S of AB equal to 1, then whether it is A equal to B, that question, okay, so you have to think over some mathematical idea, right? Of course, it is once it is told, it is very easy, right? When you think over as a mathematics, it is a little difficult, right? You see, we are going to take it here 1. What would be the idea? What would be the idea? How I can come to AA equal to BI, because I want A equal to B, right? So identicality, right? Therefore, AA equal to BA I want, and WA equal to WB I want, and P of A, P of B, everything I want, okay? Right? If you have AA and BI and WA equal to WB, then obviously this P of A and P of B will be equal, right? Therefore, I want these coordinates must be same, right? So for this, what would be the idea? It is equal to 1, you know, right? So that is the thing we are having, right? Here it is positive, and this is also positive, right? Greater than 0, and less than or equal to 1. That is important here, right? Both are less than or equal to 1, right? When I have two positive entries whose multiplication becomes 1. If you have this answer, then you have done it, right? So you know this AA equal to BA will come when this factor equal to 0, right? So this AA equal to BA, this factor must be, right? So for this, what would be the idea? This is greater than or equal to 0 and less than or equal to 1. This is also greater than or equal to 0, less than or equal to 1. Two positive number, right, whose modulus value is less than or equal to 1 is multiplied and it is equal to 1. When it is possible, both factor must be equal to 1. Am I right? If any one of the factor is less than 1, then based on which, when I multiply, then it should be strictly less than 1 only, you know. Right? If these two are identically equal to 1, then only their product is equal to 1. Right? Am I right? Am I right? So these two are now same. Since they are same, now you can verify. Okay, since the product of 1 minus modulus A B equal to 0 is equal to 1, then obviously the multiplication and all you can verify. Therefore, A equal to B will come, and here the same way. Okay, so this is equal to the 1, you know. So based on which I can get it WA equal to WB and all, because this factor is equal to 0. Therefore, I can equate maximum and minimum, both are same, right? Minimum and maximum it is same means obviously it is everything is same. Okay, that is the idea. Okay, right. Now, so this is identical. This is stronger version than the similarity measure, right? Now there's a comparative. Okay, it is symmetric in nature, that we have already, right? Then for any two real number, A comma A comma A comma A, this is the real number, you know, right? Already we have seen several times. For A, this is our real number, right? So A, all the foods remains A, and 1 is our height. Okay, that is the real number A. and B is another real number, then obviously the similarity between these is nothing but 1 minus of modulus A minus B. Of course, we know, right? Whenever I have two real number A and B, what is the distance between them? Modulus A minus B, isn't right? So, right? So whenever I have two real number A and B, the distance is modulus A minus B. Therefore, similarity is 1 minus of modulus A minus B. That is the useful ordering principle, right? Therefore, this principle, it is the generalization for the similarity relation defined on the collection of real numbers. Therefore, the validation is done. Okay, so these are the basic things that I want. Right now, so we have done it. Okay, one new definition we have taken, just small modification and small imitation. Right. So that is the research, So yeah, several times I used to tell. Right. The epsilon movement only we want. Right. So we cannot escape from the epsilon delta. Right. Am I right? So this epsilon movement, my teacher, they usually used to tell, okay, every day you have to study at least the epsilon movement. Okay. Of course, by Archimedean property, you can reach any level. Am I right? Right. So by movement of epsilon every day, obviously I can reach any level. Right. So for this also, for a motivation, I used to tell, okay, so that Thirukural and all. Right. So there is one Thirukural, of course. Tamil people, they may be knowing, right? Pilipai Saadum Achirum Apandam Sala Migutupai. That is the Tamil one. In English, okay, whenever we add the peacock feather, even it is a soft, by adding this peacock feather, it is added again and again. At one stage, this will break up the axis of the chords. That is the meaning of this particular Thirukural, right? You see, peacock feather is a soft one. That means it is equal to epsilon. But epsilon is not equal to 0. It is greater than 0, right? So it has some mass and weight, right? The peacock feather is soft, but it has greater than 0. When you add again and again, then n epsilon will give a greater force to break up the axis of the chords. Okay, that is nothing but our Archimedean property, right? So for doing research, for studying mathematics, the epsilon is very much important, right? So by means of movement in epsilon every day, of course you can cover the entire syllabus at one point. Okay, that is the way of studying, right? That is why the people, they used to tell you study every day, right? At least what it is covered in the class that you study, right? That is enough to cover the entire syllabus, right? So the research is also done the same way. So we are moving a little bit, right, to have a betterment. How it is betterment? So that again we have to study the drawback and all, right? From the existing similarity, right? So we have 2a and b, two trapezoidal fuzzy number. It is taken, right? Here it is 0 and it is 1, right? Therefore, this a is nothing but our 0, right? Because even the coordinates are given, but the height is 0, therefore this will give again this line only, right? And the b is again the another trapezoid, right? So now, what about the distance between these two? So Wei and Chen, they are identifying with 0.1759, but that is not correct, 0.1759, it is a distance between 0.0 and 0.17, right? But we want distance between 0 and of course around 0.23, right? So this one is nothing but around 0.23, right? Therefore, around 0.23 it is greater than 0.2, right? So then another one is 0. What would be the distance between them? It should be near to 0, right? Definitely it cannot be 0.179, right? Because it is almost near to 0.2, Therefore, that is not correct. But here in the new definition, it is nothing but 0.086. Of course, it is reduced to our expected level of expectation. Is it okay? This is one drawback, it is rectified. And you see one more, right? So two, again, fuzzy numbers it is taken, right? A and B. So again, we have compared with the Wei and Chen and our own, right? So again, okay, his definition gives 0.176 and it is lesser, right? So small idea we have changed, by which we have got the betterment in the similarity measure, right? Okay, that is the thing. And of course, we have taken another 4 generalized fuzzy numbers, and we have identified S of AB and S of CD is remaining same according to Wei and Chen, but that is not correct, because you see, what is A? 0.1, 0.1, 0.2, 0.3, and 1. Okay, and what is our B? B is 0.4, 0.4, 0.6, 0.6, 1. Right? So that means A is nothing but our 0.1, 0.2. Right? That is the interval. Right? So this is the interval with the Gradle value is 1. Right? Therefore, this is our interval A, and B is 0.4, 0.4, 0.6, 0.6 means what? It is the interval 0.4, 0.6. Okay. Then what would be the distance and similarity? Right? That we are going to identify. Similarly, for C and D also you are going to identify. Okay. Then that distance is remaining same according to Wei and Chan, but that is not correct. But for us it is different. Okay. So that is the thing we have. Right? So that type of betterment and all we have done. Okay. So for justification it is all done. Okay. Right. So already it is 1 hour 28 minutes. Right. So now it is my time to consultation. Right. So we have studied the similarity measure on the collection of fuzzy numbers. Of course, in the generalized fuzzy number also we have seen, right? So this is the area which has enormous application in the data science. Okay, so particularly the clustering and pattern recognition is one of the area, right? Of course, in the multi-criteria decision making, there is one method. It is called fuzzy Topsis method, right? So fuzzy Topsis method is one of the method available in the data science for MCDM problems, right? So it is nothing but, so you see, just for motivation I tell you can read the research papers, right? So I want the best one, right? So the maximum is the best one, right? But I don't get that maximum as a solution. Then what I can think over, who are very close to maximum, they are the best one, right? Am I right? That is the way of approximation, isn't right? So I want the best one. If the best one is not available, then I can think over a person who is very close to best one, right? Therefore, whenever we think about the close to the best is given by maximum, right? Then close is given by similarity measure. Therefore, the Topsis method is nothing but is application of the similarity measure on fuzzy numbers, right? So it has a wide role in the data science, okay, in the multi-criteria decision making. Multi-criteria decision making is the base for all supply chain management, right? So from the warehouse to customer, we have lots of decisions is to be taken, right? All the decisions is depending on the real number system and imprecise information based on which we have application and all. Okay, so that and all we can think over, right? So this is the application of this particular domain and all, right? So what we have learned is, okay, so we started with fuzzy numbers and of course fuzzy logic and fuzzy numbers and its similarity measure, the definition and all, and how the research is going on the similarity measure on the generalized fuzzy numbers that we have seen. Of course, it is another domain, inducing fuzzy logic. It is another domain, okay. It is a generalization of the fuzzy logic, okay. Here in the fuzzy logic, the sum of the truth function and non-truth function is same, right? But in the inducing fuzzy logic, it is not required to have, okay. So that is the thing we have. So based on which the another research domain is opened, okay, in which again the I am a liar, the statement, okay. So if some of you can tell, okay, the truth value is 1, some of you can tell 0. The remaining people, they may tell, okay, in between, you know, right? That means without telling anything, right? So those can be modeled by means of the Turner source inducing fuzzy logic model. Okay. So here also there are lots of researches going on, okay. So it is very much useful because wherever the incompleteness is there and all we can, right? In our real life, okay, many things it is an incomplete one because it is depending on the expert's knowledge. All the time experts are not God and they are not one, right? Therefore, we can have some incompleteness that can be modeled by means of this lack of incompleteness and all, right? The lack of incompleteness is nothing but 1 minus of mu minus nu, okay? So that is the thing we have, right? I don't go more on this particular because our title is only similarity measure on the fuzzy numbers, okay? Right. So I stop here with this, okay? I come to the particular slide where everyone we are expecting, you know, right? Thank you, right? So thank you one and all. I thank Saini Madam and Sunny Sir and TT Sir, who are the base and foundation for this particular lecture. Okay, of course, this is arranged as a special lecture on Uni Sir memorial, right? I thank that memorial and all. Okay, so who are all involved in this particular conference? Okay, of course KMA, right? So without the name KMA, I cannot close it, right? So the KMA is the association which is doing lots of support to our young buds of mathematical researchers. Okay, so I thank KMA and the backbone of KMA, Sunny Sir and the TT Sir. Thank you all, please. If you have any queries, you can raise at this point. So I stop sharing, I will come to this part. Okay, so here you can raise now questions, right? So my video may be on. Okay. You can pin my video if you want at so V Lakshmana Govinayakam at this. Okay. Actually, madam, you have given Gmail ID vlakshmanagovinayakam@gmail.com, but I am using sugamadi04@gmail.com. Okay, that is so you have made me as a important member. Okay, but for the Gmail ID vlakshmanagovinayakam@gmail.com. Okay, that is why I couldn't present at that time.
Sugamadi.
Yeah, Sugamadi04@gmail.com. Sugamadi is my daughter name, so based on which I have made that ID.
Okay, sir.
Okay, ma'am, if any questions in the chat box and all, I can try to answer.
Your participants, any questions? Any doubts? Anne Mary?
Yes, ma'am. I hope there is no queries. Thank you, sir.
Okay, thank you. Okay, thank you. Because it may be new to the people. This domain may be the multidimensional domain. Okay, so whenever they find a problem on my slides, okay, so the slides will be given to Saini Madam. Okay, so that may be shared with our participants. Right, at any point of time, they can catch me in my mail ID. Right, verulakshmanan@naw.edu.
Thank you, sir.
Thank you, Anne Mary and Saini Madam. Sunny Sir, I want to see your face, sir. Sunny Sir. Sunny Sir and TT Sir, already I have seen in the time of inauguration. Okay. Okay. Thank you, Madam. So you can.
Words of thanks, please. For the last 1.5 hours, we have been listening to the great personality, Dr. Lakshmana Govinayakam, HOD of Mathematics, NIT Trichy. We were going through the world of mathematics through fuzzy numbers, different types of fuzzy numbers, fuzzy logic, their properties. I extend my sincere thanks for your virtual presence in this conference and for delivering an excellent lecture. Also, I remember once I told you, sir, my first research result was a continuation of your paper on
thank you.
Score function.
Remember. Thank you. Thank you.
Thank you very much, sir. I assure you, participants, this talk will be a motivation for your research scholars. Once again, I thank you on behalf of all the participants present here. Thank you, sir. Thank you.
Shall I wind up, madam? Shall I close this call? Shall I close this call, or shall I should I?
You can drop, and all of you can drop.
Yeah. So now it is
only for the participants. You will have the paper presentation session 1. Paper presentation session 1 will be at 1:30 p.m. And for that, only those participants in session 1 will get the Google Meet link. Not all, only those participants in session 1 will get the link. After that, all of you will get Google Meet link for the second session, second lecture by 2:30 p.m. New Google Meet link at 2:30 p.m. Now, first session of lecture paper presentation at 1:30 p.m. Any doubts? If so, you can leave. There's a feedback form. You can, and Mary, what's the feedback form?
It's given at the chat box. Kindly please fill the form. So the morning section is over. The next section will start at 2:30 p.m. and the link will be provided to WhatsApp and mail at 2:50. So thank you all.
About Wasir Hassan Abdi. Professor Abdi was born in July 1st, 1922 in Jaunpur. He took his MA Mathematics from Aligarh Muslim University in 1942. He got his PhD from Lucknow University in 1962 under the supervision of R.P. Agarwal for his thesis entitled Q Laplace Transforms. He was awarded honorary PhD from the University of Adelaide, Australia in 1969. His teaching career started in 1943 in a degree college in Lucknow and then worked in many places in India like RAC Srinagar and Aligarh Muslim University. The last lap of which was in the Cochin University from 1977 to 1982 as a founder professor of the Department of Mathematics. His research interests were in discrete analytic theory, basic functional equations, and history of mathematics. He produced 7 PhDs and authored many research papers in these areas. He was politically very conscious, took part in the Quit India movement, and after independence, he moved to the Marxist ideology, which he continued to his death. Now, I would like to invite Dr. Sibyl Jose, Joint Convener, ICET-MS, to welcome the resource person, Dr. K.K. Jose, Honorary Director, School of Mathematics, Statistics and Data Analytics, MG University, to the lecture session. Ma'am, please.
Is Joseph present here? Sorry for the inconvenience.
Hello?
Joseph, can you hear me?
Hello? Hello?
Sir?
എന്തോ ഒരു നെറ്റ് പ്രോബ്ലം ഒക്കെ
Okay, sir.
അതാണ് പ്രശ്നം. ഹലോ?
Hello, sir.
10 minutes wait ചെയ്യാൻ പറയാമോ? 10 minutes wait.
Hello, sir.
I have some network problem, so I am trying my best. I cannot show the slide actually. So
Okay.
the slide is not coming.
Okay.
I will. I am trying my best.
Thanks.
Otherwise I will read the slide. അത് കിട്ടുവാണെങ്കിൽ അയച്ചു കൊടുക്കാറുണ്ട്. അത് അങ്ങോട്ട് അയച്ചു കൊടുക്കാറാണ്. അയച്ചു കൊടുക്കാനും പറ്റുന്നില്ല. അത് അപ്ലോഡ് ചെയ്യാൻ തീരെ ഇല്ലാഞ്ഞിട്ടായിരിക്കും. ഇപ്പൊ ഞാൻ വന്നേക്കുന്ന റിപ്ലൈ കൊടുത്താൽ മതി.
What happened, Joseph?
എനിക്ക് അത് ഷെയർ ചെയ്യാൻ പറ്റുന്നില്ല, അതാ പ്രശ്നം. അതർവൈസ്
സ്ക്രീൻ ഷെയർ ചെയ്യാൻ പറ്റുന്നില്ല.
ഷെയർ ചെയ്യാൻ പറ്റുന്നു. ഞാൻ അങ്ങോട്ടൊന്ന് അയക്കാനായിട്ട് നോക്കും, അതാ പ്രശ്നം. ഉള്ളി തന്നെ.
ഇങ്ങോട്ട് അടുപ്പിച്ച് വെക്കോ, ഇവിടെ നെറ്റ് കിട്ടുന്നു.
Okay. Full screen ആണോ? ഹലോ
Yes, sir.
ഇപ്പൊ കേൾക്കാവോ? മൈക്ക് ഓൺ അല്ലേ?
കേൾക്കാം സർ.
അതുകൊണ്ടാണ് ഞാനത് ഓൺ. മൈക്ക് ഓണാ? കേൾക്കത്തില്ലെന്ന് ചോദിച്ചു. ഒന്ന് റെസ്പോണ്ട് ചെയ്യാമെന്ന് ചോദിച്ചു.
കേൾക്കാം.
ക്ലിയർ ആണ് സാറേ.
ഹലോ
ക്ലിയർ ആണ് സാറേ, കേൾക്കാം.
ഹലോ
സർ കേൾക്കാവോ? സർ പറയുന്നത് ഞങ്ങൾക്ക് കേൾക്കാം. സർ
ഹലോ
സർ പറയുന്നത് ഞങ്ങൾക്ക് കേൾക്കാം.
ഹലോ
ഹലോ സർ. സർ
ഹലോ ഹലോ ഓടിപ്പോ കേൾക്കുന്നുണ്ടോ? ഞാനൊക്കെ അല്ല, അത് കാണാൻ പറ്റുന്നുണ്ടോ? സ്പീഡ് കാണാൻ പറ്റുന്നുണ്ടോ? ആ ആയിക്കോട്ടെ ആയിക്കോട്ടെ. താങ്ക് യു. ഇനി വേറെ ഹലോ ഹലോ ഗുഡ് ആഫ്റ്റർനൂൺ. So sorry for the delay. So that was actually due to Spanish problem. So my topic is actually biostatistics applications and challenges. So what is actually biostatistics? So we will start with what is biostatistics? So it is actually a discipline discipline seeking a solution to. So discipline, what is biostatistics? We will start with the definition of biostatistics. It is a discipline seeking solution to political problems using statistical theory, large-scale computing, and analysis of data. Bio means life. So biostatistics is enhancing our understanding about biological phenomena, public health issues, epidemiological problems, disease growth, drug development, and trials, vital statistics, population dynamics, demography, ecological and biodiversity issues, bioinformatics, etc. So, the continuation of that, it is actually primarily quantitative study of health indicators of human beings, animals, fishes, plants, ecology, biodiversity, climate change, etc. So it actually it's the demographic and vital statistics like birth rate, death rate, mortality rate, incidence rates, case fatality rate, morbidity rates, human mortality rate, life tables, population growth, etc. So one of the main branches of statistics is actually epidemiology. So dealing analysis of disease data, survival analysis, and more. So biostatistics also deals with the clinical trials for drug development, based on efficiency of medicines, safe dose estimation, bioequivalence, and biosimilarity. So what are the parts of a biostatistician? So what should play a key role in helping pharmaceutical companies in the drug development process through planning and design of clinical trials, helping reduce risk, decrease costs, accelerate timelines, ensure speed results, and improve the quality of regulatory submissions. There are also significant challenges regarding pricing, profiling, etc. of new drugs, in which biostatisticians play a significant role. So I will just consider the important biostatistical measures which we are familiar with. So in biostatistical measures, so the main consideration is that is sex ratio, birth rate, etc. So students, many of you have studied in the high school classes itself. Then small rates, birth rate, death rate, crude death rate, age-specific death rate, cause-specific death rate, life expectancy at birth, life expectancy at a given age, infant and maternal mortality rate, then case fatality rate, then morbidity rates. Morbidity is actually associated with the diseases, incidence rate, prevalence rate, odds ratio, etc. So mortality rates are actually considered our human beings, our life, our death rate, our age-specific death rate. Age-specific means a person, suppose a person is having 60 years age, then how many years he will live? That is actually something we can know. Age-specific actually means, so suppose you are of age 60, then what is actually the death rate of persons of age 60? That is actually something. So I will come to in detail. So the growth rate, that actually is actually denoted or measured by the ratio dy by py, and that is assessed in terms of 1,000. Out of 1,000, how many? So dy, that is the number of deaths in an year, and py, that is the median population size, usually the population size on unit per year. So dy by py 1,000 actually gives you the CDR, the crude death rate. Then comes the ASDR, that is actually the age-specific death rate. Age-specific death rate means, as I have already told, I have specific ages mentioned, or some age group 60 to 70, 60, or and so Indian population, and those who are aged at 60, how many are dying in a year? So DA, that is the number of deaths in the age group A. Then PA, that is the median population size in the age group A. That is around June 30th. How many people are there of age 60? Then how many are dying? Age at the age say 30. So you consider all those who are of age 30. Then the ratio DA divided by PA into 1,000, that will give you the age-specific death rate. Then comes IMR. IMR is actually infant mortality rate. So infant mortality rate means the number of infants died. That is actually the DA. It is the number of infants died during a year divided by the number of live births. That is actually B, and that is also expressed in thousands. So this way we can have different types of mortality rates. So I have just given some examples. Many of you might have been familiar with these things even in high school classes. So we are doing some of this. So now I will be coming to classical problems statistics and statistics. That is what we refer to as T experiment. So here the problem is very simple. So by the time in the Cambridge or in the University College London, so every afternoon they have a tea party at 3 p.m. So one day a lady made a challenge. I can tell whether milk is poured first and the tea is added next, or whether tea is poured first and the milk is added to the tea. So many of you listening this talk, so are familiar. Can you tell the milk is poured tea or is poured milk? So I was actually, so the lady was very confident and she said, I can say this. So people that so there was actually Professor is known as the father of science. Professor Fisher actually introduced the concept of randomization, the hypothesis, maximum group estimation, many things. So he made significant contributions. So most of the contributions in modern statistics. So he was there. He was actually the prominent in that group, and he actually took up the
ഓഡിയോ കുറച്ച് ക്ലിയർ അല്ല, ക്ലിയർ ആക്കാൻ പറ്റുമോ ഓഡിയോ?
She may say correctly. Sometimes she may be fully wrong. So that means 1/2, that is the probability for making a correct statement. So now suppose you are giving 2 cups. It will be 1/4. So suppose both cups are of tea. Both 1 cup may be having tea added to milk. 1 cup may be having milk added to tea. So in that case, it would be 50%. Then both are correct. So either 0 or 2. That is actually 25%. So as the number of cups of tea increases, there is only little chance. So actually what happened was Fisher prepared 10 cups of tea and he brought it 8 cups of tea. So Fisher proposed 8 cups of tea, and the probability for making a correct judgment is actually 1/2 which is very, very small. So the lady was very clever, and it says that she had done, or she had made the predictions very correctly for all the 8 cups. She was able to say whether tea is added to milk or milk is added to tea. So that was actually correctly done. So actually, this experiment gives you some idea. So with just one experiment or with just one person, so we cannot have an experiment. So you should have a number of. So then only randomness and variation will be there. Then only we can make use of statistical theory and probability theory. So that is actually so that is actually so this experiment or this incident actually led to the development of one of the classical theories in statistics, or that is known as the design of experiments. The branch of design of experiments actually was developed because with this. So that is actually replication or repetition of the experiment. Repetition, repeat it many times. Then randomization. So you randomly allot. So there should not be any systematic way. So you randomly give these cups. So that is actually the thing. Then some repetitions, blocking also may be there. So now I will be coming to the fundamentals of epidemiology, or how you can make a modeling in epidemiology. So the study of the distribution is actually concerned with the study of the distribution, frequency and determinants of health problems and disease in human population. And the purpose is to obtain, interpret and use health information to promote health and reduce disease incidence and its impact. And for example, suppose we are facing now COVID-19. So you may be concerned with developing a vaccine against this, how to treat this, what about the number of persons affected by diseases, what about the age group, whether there is any sexual differences, whether it is more common with the male people or female people, or more common with the older people or young people or youth. So whether all these dynamics you have to study, that is the purpose of an epidemiological modeling. So I will come to modeling. So in mathematical or statistical modeling, we are having mainly 7 to 10 steps. The first step is actually you identify the problem. So what is the problem to be studied? So whether you are going to develop the growth pattern of COVID-19, or whether you are going to consider the age distribution or the incidence, or what about it? So what you are concerned with, or the lifestyles. So identify the problem. After identifying the problem, you search for existing knowledge. Usually that is referred to as review of literature. Then having review of literature, you identify the gaps. So many problems or many things may not have it been studied. So that you identify the gaps. Then you collect the data and formulate the model. So based on the data, you formulate the model. Then you can either propose a mathematical model or a statistical model, and you can arrive at a mathematical solution or a statistical solution. What is the difference between mathematical and statistical models? In mathematical model, you are giving an exact model, whereas in statistical model, there will be a random component. So in many cases, so everything in nature that is complex, that is unpredictable, so that we can make use of the random component. So even if you consider the price, so the law of demand, if you make use of, so according to price, the demand will vary. So whether that is exactly in the mathematical form or whether there is some random variation. So usually random variation is more familiar or more common. So that is why we may be concerned with a statistical solution rather than a mathematical solution in many of the advanced studies. And so you can make use of mathematical techniques to solve that and arrive at the solution. Having obtained the solution, you have to interpret it. So what is it? So you have to explain it to the minister, or you have to explain it to the manager, or you have to explain it to the secretary of the health department, or to the doctor, or associated with that, or you explain it to the scientific community. So in that case, so examine whether your conclusion or your solution is a feasible, is a biologically feasible, theoretically feasible solution, and so on. And once you are confident that it is a correct solution, that is actually it is in agreement with the scientific theory, then you can compare with the real world model, and you can compare with the model validation. That is actually known as model validation. So suppose you have developed a model for rainfall. So this much rain may be observed during the month of October. So suppose you have developed a model during 2020. Suppose you have developed a model. Now you have to verify whether it has been correct. That is actually you make use of the data up to September 30th. Then you just predict the values during October. So if the values are somewhat coinciding or somewhat identical or somewhat similar or somewhat nearer, then certainly you can validate, you can say that our model works well. So then you can proceed with a report writing, then you can make presentations, then you can send publications or send for publication in internationally reputed journals. So these are actually the different steps in the model development. So that is true with any mathematical model or any statistical model or any biostatistical model. So in biostatistical situation, so you are asking some questions. What are the key questions? So the key questions are, what is the health problem? This is condition, or its manifestation or characteristics. So what? That is actually the first question. And the second question is, who is affected? Who? So what is the age? Which age group? Which sex, male or female, or without any difference? Or social status, depending on, so whether rich people are more affected, whether the poor people are more affected, whether those working white collar people, persons of white collar jobs are more affected, or those in the casual workers are more affected, or whether there is some difference between ethnic groups, whether some community differences, Christians and Hindus and Muslims, whether there is any such differences. So all those things, so you have to verify. That is actually the thing. So who is affected by this particular disease? So that is actually the next step. Okay. Hello. 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 What is the health? So who is affected? Then comes where. Does the problem occur in relation to place of residence, geographical, and place of exposure? Problem actually. So whether it is more common in hot countries, or in hot season, or summer season, or winter season, some such situations, whether it is more common in cities rather than villages, and rural places or urban places, all those things. When does it happen in terms of days, months, and season or years? So whether there is some such peculiarity. No. So what is the season? Whether it is more common with winter season, whether it is more common with the hot season, summer season, or whether it is more common with June, July, or whether it is more common in December in cold climate, and so on. So how? That is the next problem. Does the health problem, disease or condition occur? Sources of infection, susceptible groups, other contributing factors. So all those problems, what are the reasons for that? So all those. So these are the key questions: how, what, who, where, when, how. So once you have some details about this, now you can proceed with the general dynamics of an epidemic. The general dynamics that is actually regarding the growth of the disease. So individuals pass from one class to another, one place to other place. So that is actually, so the COVID case. So people from foreign countries abroad, they came to Kerala or they came to India. Then people from other states came. So whether there is such spreads are, the epidemiological model tries to capture this flow by using compartments, or how it is actually, what is the manner of growth, what is the way in which the disease increases, or the population affected by the disease increases. So for that, actually, usually we are more concerned with the basic reproductive ratio. So usually the basic reproductive ratio, in the beginning it was just 0.2 or 0.3, etc. for COVID case. Now it was increased. So during May, June, etc., it was actually 2 or 3. Now, so in Kerala it was less than 2 actually. So in Maharashtra, in Delhi, etc., it was more than 4. Now it has come down. So that is actually the so. So we have to determine this. So these are actually the parameters associated with the model. The ratio determines whether an infection can occur, determines whether disease will progress or not, growth rate of infection, speed of disease progression, asymptomatic period. What about the period? So usually 14 days is assumed for COVID growth. Actually, the virus will come to will develop in 14 days. That is actually why quarantine is suggested for 14 days. So determine time to progress to disease, necessary effort to controlling the ratio of parameters, we can control the disease. So that's why we are going to estimate, or you are going to search for the value of basic reproductive ratio. So I will just show the mechanism. So here, so from 1 person it actually already passes to 2. From the 2 it actually goes to say 4 persons. So here the reproductive ratio that is actually equal to 2. So that is actually the specialty. Now suppose it is equal to 1.4, this will be the way in which it is growing. So from 1 person to 1, then from this person out of 3 only 1, then comes out of 3 it goes to 2, and so on. So the transmission rate is little bit less actually. So that is, so if it is 3 it will be at a higher rate. It will be, if it is 4 it will be at a very high rate, and so on. So this way we can study about the manner in which the disease spreads actually. So the reproductive ratio, that is actually an important parameter. So for that, actually you develop the model using our mathematical and statistical principles, and develop certainly mathematical equations, something like our queuing models, our stochastic models, our probability models, etc. So you develop these models and you solve these equations using the conditions, then you will be getting the solution. So here the solution has been obtained. Having the solution, so you can come to say the final answer. So what is actually the way in which it goes? So what is the mechanism? So all those things you can solve these mathematical equations, and you can obtain some curves also. So this actually shows. So this is just an example to show whether the COVID the curve has come down. So here there is at the point A it comes down. So during say this November, so in Kerala it will be big, then it will come down. In other countries, or in Maharashtra, Delhi, etc. So it was already at the peak, then come down. So in other countries also, in Italy, it was at a peak during February or March, you can say. So now the curve was turned down actually. So this is how we can mathematical equations and statistical models actually. So that is actually the first step. Now I will be coming to the biostatistical study in the new era. In the new era means in the new present era, you can say. So here, so that is actually because of big data. The raw material of a biostatistician is data, and the present era is that of big data actually. So it is not systematically collected. So big data, what about big data? Big data is not the usual statistical data. It is not a statistical data. It is actually not systematically collected, but it contains information. Suppose you consider your the SMS to you or the emails to you. So these are actually giving some information actually. So your SMS, that will give you your likings, your behavior, your interests, and so on. So that is why many data science companies are actually, data analytics companies are searching for that. They will find some pattern in that, and they will trace out some indirects, etc. So some takes and prints, etc. So even though it is not a systematically collected data, it contains information. So for that, actually, data warehousing, data mining techniques are needed. Computer programs are also to be developed. Data quality is important. Data cleaning is essential. So the data should not be used as it is obtained. It should be clean. That is actually what is actually more common with big data and data science and data mining techniques. Now, what are the new challenges? So the new challenges, biostatistics is a fundamental scientific component of biomedical, public health, and health services research. Traditional and emerging methodological and application areas include clinical trials. You might be familiar with the clinical, so you have heard in the newspapers about clinical trials for the COVID vaccine, then observation studies, imaging, and genomics. So imaging for neural, something regarding brain and so on. So genomics actually genetic structures actually, the genetic codes and so on. So the DNA structure and so on. The next decade maybe the most exciting era in the more than 50 years history of biostatistics in medical and biomedical research. So that I have taken from a journal, a recent journal article. The opportunity to contribute to the identification of new genes which contribute to disease, the development of gene transfer strategies and gene therapeutic clinical trials, and the development of novel pharmaceutical or biological for the treatment of prevention of disease is enormous. However, the shortage of biostatisticians with training in genetics, molecular biology, and bioinformatics is often limiting actually. So many of the biostatisticians are mathematics students, so they may not be much familiar with molecular biology, bioinformatics, genetics, etc. So if you want to excel in biostatistics, so you have to be very good in all these biological areas also, including special topics such as clinical trials, survival analysis, bioinformatics, basic biology. Along with that, you should have good communication skills and leadership also. The demand on leadership is likely to be even greater than in the past. So since you have to explain this to the people, you have to explain this to the company owners, you have to explain it to the scientific community, you have to explain it to the doctors. So they are not much statistically or biostatistically experts, or they are not good experts in biostatistics or statistics or mathematics. So what about the global scenario? The global scenario in a 2016 paper, so they say biostatistical science is in a golden period at present. Biostatistical science consists of the application of statistics, probability, mathematics, and statistical computing to advance our understanding of the subject matter in the biomedical sciences. This field is experiencing unparalleled developments now with the emergence of data science and data analytics. That is more important. So now, everywhere you hear about data science and data analytics. So this was actually revolutionized all of our concepts of statistics and mathematics. So data is more precious, more powerful. That people have realized that these industry people have very clearly understood its significance. So they are actually making use of. There is due to the recent developments in information technology and computer science through data science. Biostatistics are becoming more global with resources which can expand educational opportunities for distant and open online learning. Even all those facilities are there. So if you are a biostatistician, you have to understand all this. You have to go for different types of training. The growth of quantitative methods in the biomedical sciences has made biostatistical science a key component in many research areas. So if you are a doctor, if you want to do research in medical sciences, certainly you should be good in biostatistics also. You should be good in biostatistical computing also. Then only you can go for that. Biostatistical science is enjoying unparalleled developments. The need and demand has never been greater. The position paper by Dimetz, a famous biostatistician, describes the growing shortage of biostatistical scientists. The shortage will become worse with time as the demand for biostatistics continues to increase and the availability of training funds goes to increase actually. So with the COVID, now actually all governments are giving funds, funds for COVID research. So for the development of COVID vaccine, for the analysis of COVID data and so on. So we will be getting good amount of money for biostatistical works actually. So we need only look at any of the current issues of statistical journals and biostatistical journals, even computer science journals, medical journals, to know the importance of biostatistical science on the new world actually. Biostatistical science is at the cutting edge of many new developments in statistics. It is mainly motivated by problems in the health sciences. It remains as that statistical theory cannot be separated from the practice or applications of statistics. So it should not be confused with the even though it is actually in a large demand. So it is not just applications, it is just not just data analysis. It actually needs more theoretical developments also. So that is why we say a biostatistician should be good in statistical theory as well as statistical applications. So when they are separate, the theory is likely to be very little. So a biostatistician should be good in theory and applications of statistics, good in data analysis and interpretation of results actually. So that is actually something which is more important. And the widespread availability of computing has led to the creation of big data and many new databases. So that is actually, so even though big data was there, now computer science has developed, now data analytics has developed, now field computing is there, field computing softwares like R, Python, etc. have come to the forefront. So that is how this big data analytics has developed. However, there is a distinction between data and information. So what is data? So data is actually something which we get everywhere. But information is actually to get the information from data. Converting data into information requires insight, skill, and training in the theory and practice of statistics. So from all types of data, you may not get information. So for that, you have to use your insight, you have to be skilled, and you should have good training in theory and practice of statistics. Now, statistics has become data science and data analytics. So data wisdom is more important. Deep learning of data is essential. So now I will come to the scenario in Kerala. So as far as biostatistical study is concerned, so in Kerala it was at the nil up to 2005. In 2005, in our department of biostatistics at St. Thomas College, Pale, biostatistics course was started. Then in 2008, it was started in Kerala Veterinary and Animal Sciences University, Mannuthi, but their prime concern was actually more on agricultural sciences. So agriculture actually, plant sciences. Then Amrita Institute, it started an MSc in medical statistics in 2010. And they were actually Amrita Institute of Medical Sciences, the medical college. So they were more concerned with medical sciences. Then Kerala University Fisheries and Oceanographic Studies. So they also started MSc Biostatistics. Their study was actually concerned with oceanographic. That is like the fishes and other water creatures, you can say. So more concerned with oceanography. Then the national scenario. So biostatistics was started first in our country in 1983 at Christian Medical College, Vellore actually. And after 25 years, it was started in Pale actually. So Bala was actually the second place. Now it has been offered by NIMHANS Bangalore, then Manipal University, then National Institute of Epidemiology, Chennai, and so on. And now the importance is actually due to the Medical Council of India's the Medical Council of India has made it mandatory to have biostatistics units for all medical colleges. So all doctors have to publish papers in research journals, medical research and publication. That has become one of the most important component for doctors in medical colleges and for getting promotions, etc. So that is how in India biostatistics has come to prominence actually. Indian Statistical Institute, All India Institute of Medical Sciences, etc. have special units for epidemiology and biostatistics. At the international level, there are ample opportunities for biostatistics. So at international level, you can say all mathematics and statistics departments are more concerned with the biostatistical works. So whether they call it biostatistics or not, they are all concerned with biostatistics. Why? So biostatistics is more concerned with health, and people are more concerned with health. That is why biostatistics has become more important there. Then, as far as biostatistics research and training is concerned, the Regional Cancer Center Thiruvananthapuram is at the forefront. Then another is actually the Malabar Cancer Center at Talasheri. So all these are actually more prominent institutions in biostatistics research in Kerala. So, but it is not enough actually. So more concentrate. So very late actually. So last week, so the Virology Institute was actually inaugurated in Kerala actually, the Virology Institute. So that was actually inaugurated, or that was actually formulated, or that was actually in the actually that idea came during the chikungunya project. So now the present government has actually inaugurated the institute actually. So good research going to happen in that. So practice of principles in biostatistics and epidemiology is done by medical and public health practitioners, doctors, and voluntary workers. However, qualified biostatisticians are seldom available. So because of that, in many cases, only very elementary things are going on in the name of biostatistics. So data is not collected systematically. Moreover, advanced statistical techniques are not employed. Only some graphs, diagrams, ratios, etc. are used. So that is actually the pathetic situation of biostatistics. So even though in Kerala, so we have been experiencing different types of these communicable diseases, these lifestyle diseases every year during June, July. So no research is going on. No study based on data has been going on actually. So that is actually the pathetic situation for biostatistics actually in Kerala. So this actually offers more opportunities for research. Many biostatistics use only elementary statistical techniques like weights, ratios, and percentages. Biostatistical and epidemiological issues need more advanced statistical theory and data analytics. The emergence of new diseases like AIDS, SARS, H1N1, Nipah, COVID-19, etc. will lead to large-scale funding for research in biostatistics. Now, in the new normal era, that is actually in the post-COVID era, certainly governments will be more concerned with these health issues, and biostatistics works will be more common, and this will be giving more opportunities for biostatisticians and those working in this area. The high incidence rates of diseases like COVID-19, AIDS, cancer, diabetics, cholera, hypertension, TB, then cardiovascular diseases, hepatitis, etc. in Kerala points out the need for research in biostatistics. Also, the emergence of diseases like chicken, dengue fever, H1N1, bird flu, etc. also urges collection of quality data with the help of biostatisticians and doctors for analysis and study. Health analytics and mapping are needed. So during this COVID season, so to identify patients, they are making use of health mapping. Health analytics, they are collecting. So the government of India is collecting the data through our mobile phones. So you have to register. So the purpose is actually to map. You have to identify a person affected by COVID disease, where he is. So suppose a person is under treatment, whether he has escaped, whether he has left the place, quarantine. So all those you can do, or you can have all this information through health analytics, mapping, etc., age, and also all those. So the more complicated information you can collect through this way. Then comes clinical trials and drug development. So another thing is actually clinical trials. So clinical trials, you are familiar, or you have read in the newspapers. So for COVID vaccine, health persons are actually more concerned with the clinical trials in India, in America, in Britain, everywhere, in Oxford, everywhere. These clinical trials are going on for drug development. In Russia, the drug has been developed actually. So what is actually this? So due to lack of adequate laws and legal measures, India has also become a hub for multinational firms and pharmaceutical companies, leading to high employment potential and salary. So that's the situation. So even before COVID, so biostatistics students were getting very good jobs because of this. So in India, too many companies are working and they are conducting clinical trials without any license at all. So even then, even though the law is actually permission from clinical trial registry of ICMR is a mandatory condition, so even then doctors and medical institutes are conducting this type of studies without any permission. Clinical trials are conducted with much precautions and legal formalities. Research based on very small samples are taken as proof of evidence. So usually experiment on 5 or 6 persons or 10 persons, that is taken as the evidence for arriving at some conclusions. So that is actually the thing. So what is a clinical trial? It is an epidemiological experiment. It is an interventional study. It is an interventional study on individuals, usually on patients. It is a research study on human volunteers to answer a specific health question. There will be a study group and a reference group. So in a clinical trial experiment, there will be a study group, there will be a reference group. So human volunteers are needed actually. So what people may not be given the disease, the medicine. So study group actually means the person who are given the medicines or given the injections, etc. So the reference group is actually the persons who may not be affected by the disease. So remember that. So now we will be coming to different stages of a clinical trial. Phase 1 trial. So as far as COVID vaccine is concerned, it is under the phase 1 or phase 2. So the first time testing in a small group of 20 to 80 persons. So when the new medicine has been developed, so the phase 1 trial is concentrating on just a small group of 20 to 80 persons. So to evaluate safety, to determine a safe dosage range, to rectify side effects. That is the purpose. So the medicine is first applied on animals actually. After the animal experiment becomes success, it will be applied on human beings. There also in the phase 1, a very small number of people are taken, human beings are taken. So 20 to 80, maximum 20, maximum 80, usually 20. So even if this is 20 to 80 people, the doctors usually take 10 to 30 and so on. And the purpose is actually to evaluate safety, whether this drug is safe with the human beings, or what is the safe dosage to rectify side effects when whether 1 ml is needed or 10 ml is needed or 25 ml is needed. So all those things. So what rectify side effects means whether there are any side effects. So in the COVID vaccine developed by Oxford University, there was some problems. So it was the experiment was actually postponed actually. So it was actually stopped actually. Then after some days actually it has been resumed. So that is actually the thing. So to rectify the side effects. Then comes the phase 2 experiment. Now in Oxford, in India, and many places in Australia, in America, in Russia, etc. This is under phase 2 trial. Phase 2 means the test is conducted on a little bit large group. That is actually from 100 to 300 persons. The drug is being administered. And the purpose is actually the same thing. Whether it is safety is the more important concern, then effectiveness, then to confirm. So if it is going to be successful, then you can confirm that this medicine is actually good actually. So that is actually the way in which clinical trials are going on. Then comes the phase 3. Usually before the COVID period, every drug should pass through phase 3. Then only it will be marketed or it will be administered at a larger scale. So in phase 3 trial, a large group of 1,000 to 3,000 persons are tested. And there also the purpose is to confirm its effectiveness, monitor the side effects, compare with the community used treatments, comparing with other treatments also. So compare with age groups, different age groups, whether children, infants, youth, old age people, or middle-aged people, or children. So whether there is any difference between different groups. What about the dosage for an young person or a child? What about the dosage for a person of age 80? What about the dosage for a youth? All those you have to decide. So to gather information about safe doses, and usually it will take 3 to 5 years. But many governments are actually, the Prime Minister is asking for developing the medicine as speedily as possible. The politicians are asking for that. But as far as the biostatistician is concerned, it should take 3 to 5 years. You have to study it in detail. So usually 1,000 to 3,000 persons are to be, the experiment is to be conducted on 1,000 to 3,000 persons. So then, if it is successful in the third phase, then certainly it can be administered to people. Then there is one more phase actually, that is the phase 4. Phase 4 is actually post-marketing studies. So after marketing, after giving this to, after giving the license, certainly the study should not be stopped with that. You have to continue the study. Sometimes some reactions may be coming after 10 years or after 20 years. So you have to continue the study for at least 10 years. So usually in Western countries, it is up to 20 years. So to know in detail about the drug risk, reactions, benefits and adverse effects, sometimes there may be some adverse effects, so which may be more prominent after 20 years. So that you have to be studied. So you have to conduct the follow-up studies also. That is the phase 4 trial. Optimal use and optimal dosage. All these things you have to develop actually. So it will take usually 5 to 10 years or up to 20 years. So that is actually the way in which a clinical trial experiment is considered or conducted actually. So for conducting the clinical trial experiment, you have to conduct you have to design the clinical trial. So that is like design of experiments. You have to design the clinical trial. You have to select a reference population. Suppose you are going to develop a medicine for vaccine for this COVID-19 in India. So your reference population will be people of India. Then you have to select an experimental population. Suppose you are in Kerala. So your experimental population may be people from Kerala or people from Kerala and Maharashtra or some highly affected, some people from Kerala, Tamil Nadu, Maharashtra and Delhi. So that is actually the experimental population. Then you have to exclude non-participants. So whether you want to exclude children, whether you want to exclude old age people. So you have to decide who are to be considered. Or suppose you concentrate just on COVID patients alone, those who are reported to have positive effects, so COVID positive. So you have to decide who is the experimental population. Then you have to select the study population or the sample. So among the COVID patients or among those in the first stage, those who are found positive or those who are admitted in the first line treatment centers, so you have to select a sample. What about the sample size? So which is the type of sampling design, whether a simple random sampling is to be made, whether a systematic sample is to be used, whether a stratified sample is to be used, all those things you have to. So what is the particular type of sample you have to use? That also you have to decide. Then the intervention group and comparison group, that also you have to decide and you have to allot the medicine. So random allocation into intervention group and comparison group. For the comparison group, usually you give placebo. That means placebo means something like a medicine, but it is not containing any medical. So it is just sugar tablets. So people will be thinking that it is a medicine. So that much. So then you make the condition, you make the comparison between the intervention group is the actual group to whom the medicine has been applied. Comparison group means the comparison group is actually the group to which no medicine has been applied. So apply intervention, then no intervention, then uniform assessment of outcomes. So this will actually enable uniform assessment of outcomes actually. So you have given the medicine to those persons affected by this, those persons not affected by this, and so on. So you have not given this medicine to some persons not affected, some persons without any disease at all. So all these groups, you will be considering the data from all these will be applied, or all this will be. So this design of clinical trial is actually something like sample selection and application of the medicines. So it is something like design of experiments actually. Then comes the study protocol. Before that, so you have to develop the study protocol. Study protocol is concerned with deciding the target population and study population or the sample, then appropriate sampling method, sample size determination and data collection, then the standards of accuracy and precision, appropriate design of experiment, appropriate test procedures, estimation methods, then conclusions and interpretations. Then data analysis also is there. Then comes to the reports, presentations, publications. All these things you have to clearly prepare. Then you have to submit it to the government for approval. then only you can carry out the clinical trial. So for conducting any medical experiment, you have to prepare the study protocol and you have to submit it to the government for the health department, to the ICMR. So whoever be the agency, then only after getting the permission you can proceed. So for that actually all these statistical things are to be explained in a brief, in a short. So the study protocol is usually of 20 to 50 pages. So you have to give all the details from where the data is collected, what is the manner in which data is collected, what is the study period, all those things, who are the persons we will be collecting. So all those who are involved in the study, all those things you have to discuss. So this is actually the thing. So now for students, I am just giving, so usually what is the curriculum for MSc Biostatistics? So usually for a postgraduate course in biostatistics, you have to study statistical, the elementary statistical methods and probability distributions. Then sample surveys for health surveys. Then usually the free software R and Python is taught as a course. Then statistical genetics and ecology, that is actually to study about the basic biology. So you have to study statistical genetics and ecology. Here actually you will be making use of some statistical measures to study about biological things. Then certainly statistical data analysis using Excel, R, Python, etc. Then comes to the semester 2. In semester 2, you will be considering matrices and regression, that is linear algebra and regression techniques. Then statistical estimation theory, then statistical testing, then epidemiology and vital statistics, then statistical computing using R and Python. Actually, there may be a minor project work also. That is for just 2 months. So you have to undergo a minor project work. In most of the institutes, they are offering this. Then comes to the third semester, stochastic modeling, time series modeling, then design of experiments, bioassays, multivariate methods, advanced epidemiology and bioinformatics, statistical computing and data analysis using R, SPSS, and SAS. So these are actually the courses during that semester. Usually for fourth semester, so you will be undergoing Bayesian inference, SAS programming, then survival analysis and lifetime modeling, demography and population studies, clinical trials and operations research, statistical computing and data analysis using R and SAS. All these things are to be studied. Certainly there will be a major project work for 3 months in a reputed medical college, actually, medical institute. Then the project presentation and Viva-voce will be there. Certainly many students published their research paper, their project outcomes as research publications also. So these are actually the common. So whatever the eligibility condition is usually BSc in mathematics or statistics or computer science. Usually some biology students having good knowledge in mathematics and statistics are also admitted subject to some conditions. So now I will come to the last part of the study. So what are the emerging challenges? So the emerging challenges for biostatistics is actually due to, so as I have already told, it's actually due to data science, the emergence of data science. So you should be good in artificial intelligence, machine learning, neural network. The emergence of analytics for big data, genomics, and microarray analysis, etc., are challenging. These are to be applied in more advanced works or more research works, you can say. New developments in genetics, molecular biology, bioinformatics, this genome project, etc., demands more expertise. Policy issues on health are to be addressed properly. So you have to, be very well with the legal formalities also. So that is like the policy issues. What about the government's legal formalities? All of these things you should be aware about. So I'm just showing a paper which appeared in Statistics in Medicine. So next day you are having study on bioequivalent studies. Professor Thomas Watt will be giving more on bioequivalent studies. So this is actually a paper which appeared in Statistics in Medicine. That is the famous journal in biostatistics. The use of asymmetric distributions in average bioequivalence. Bioequivalence is actually some similarity, some corresponding to a particular medicine. So an equivalent medicine is developed. Suppose a medicine is used in America, so it will be costing say $10. $10 means it may be costing some 700 or 800 rupees. But suppose it is produced in India, then it may be costing only some 70 rupees. So that change. So you have to examine whether both medicines are having somewhat the same effect. So that is actually the problem of bioequivalence. So you will be studying in detail tomorrow. Then comes to clinical research. So what are the research directions? Clinical research is typically done in 4 phases through which biostatisticians are involved. This is actually clinical trial and that's actually. So I have already explained that. So from the design of the clinical trial to identifying what data should be collected. So if you want to do research in biostatistics, certainly, usually most research will depend on the clinical trial experiments also. So you have to develop new medicines, new theory, etc. So for gathering the data, interpreting and analyzing it and report generation with appropriate statistical and scientific interpretations. We also deal with challenges as missing data, interim looks, multiple hypotheses, multiple endpoints, etc. Biostatisticians are involved in the development and improvement of devices and diagnostics, not just medicines alone. Some equipments also you have to develop. So good biostatisticians who are good in this engineering actually. So may not be for biostatisticians, but bioengineering is also another area. So for bioengineering people, so you have to be very clever in this development of these equipments also. So not just medicines. So big data analytics is needed for this. You have to develop programs, you have to develop computer softwares. All those things are also part of biostatistical studies or biostatistical works. So now we will be coming to just a picture to show statisticians reduce disease and improve medicines through the study of the DNA structure. So that is actually genetical corrections. So some genetical corrections are, so this is actually the new developments. Genetical corrections you can do, decoding of the genetical works or genetical DNA structure and so on. So modifying that. So that is actually the way in which research is going on. Another is actually, suppose, so you want to study about patient's cancer, a cancer patient, then you can make use of doctors from abroad also. So you can make use of, you can work with a doctor working in USA, you can work with a doctor working in Japan, then maybe in Russia, maybe in India. So all these persons will work through computers actually. So through the internet. So that is actually how so the disease, the treatment is going on. Then another is actually through DNA structure. So they are actually consulting. So whether the DNA structure of the patient is being studied in detail by groups of doctors. So now I'm going to conclude. Biopharmaceuticals. Biopharmaceutical industry is challenged more than ever by regulatory and other competitive pressures. That is another one. Regulatory means legal measures. So governments are imposing more conditions. The industry is in a quest for better and cheaper medicines. So as in the case of COVID situation, so you have to obtain cheaper medicine, better medicine at as quickly as possible with the positive results and reduced risk and reduced cost also. So all this is another thing. The industry is in the industry, then the government, the medical department, they are in a quest for better and cheaper medicines that reach patients with unmet medical needs as quickly as possible with positive results and reduced risk. The changing dynamics have presented new opportunities for those who can help business and regulatory leaders to make quick and accurate decisions about drug development and market authorization. So you are not going to make drug. So you are just supporting this process. You are supporting the biochemist, you are supporting the doctors, and so on. So biostatistics is just supporting this. You are collecting the data, you are analyzing the data, you are giving the interpretations. Certainly the experiment is conducted by the doctor actually. So the future, the knowledge of touching a patient's life, no matter how indirectly, makes biostatistics a meaningful and rewarding career. So your results, your conclusions, your interpretations, your data analysis, etc., are actually to save the life of a person. So to save the life of millions of patients. Suppose a new COVID vaccine is developed and the biostatistician analyzes the data and say it is okay, and say this medicine is better than the other medicine. So certainly your conclusion or your decision is actually going to affect the lives of thousands of people, thousands of patients. So it is certainly a meaningful work, it is a rewarding work, it is certainly a responsible work also. So you should be very responsible. You should be aware about the patients. You should be aware about touching a patient's life. So That is the seriousness by which biostatistical work should be done. The new era of big data analytics have presented new opportunities as well as challenges. New areas like genetic correction therapy, health analytics, disease mapping, etc. are emerging and challenging. So all these are actually in the developing stages, not yet developed much. Just for research purpose, some people are using, some expert doctors are using. And biostatistics play a key role in helping biopharmaceutical companies in the drug development process through helping reduce risk, decrease costs, accelerate timeline, ensure speedier results, and improve the quality of regulatory submissions. So you have to develop, say, marketing also. You have to make significant challenges regarding pricing. So what about the price to be decided? So the profiling of compounds in which biostatisticians play, that is actually marketing everywhere, advertisements, all those things. Also the role of statistician. And finally, there are primarily two career paths for a biostatistician. One is as a statistician come data analyst, and the other as a statistical programmer. They are not essentially exclusive paths. The statistical program is different from a software program, as performing statistical analysis of data requires understanding and insight of data from clinical trials. So he should know the disease mechanism also. He should write the softwares. That is actually the software for analyzing the data. So a biostatistical programmer should be able to write programs. So he should be well versed in R and Python. So with the data analytics, so he should be good in data analytics. So that is actually the most important thing. So I will just show some papers which have appeared very recently on future of biostatistical science and the future. They say biostatistical science is in a golden period. So this paper appeared very recently. Another paper which is a another paper, so which say accurate estimation of influenza epidemic using Google search data. So actually data is collected from Google, then it is analyzed. So for that actually data science, data analytics, machine learning, etc. are needed. So actually it is from biostatistics, biostatistics that this data science, data analytics, etc. have emerged. Or biostatistics gave questions actually, and computer scientists have developed the technology actually. So computer engineers and computer scientists have developed this. So the prime question was actually from biostatisticians. So how to analyze this type of big data? So we cannot do it with the usual statistical techniques. So actually computer programmers, computer science engineers, etc. came with their artificial intelligence, data mining techniques, data warehousing techniques, neural networks, machine learning techniques, etc. That actually developed to that is actually the scope for biostatistics. So data science has been there for the last 50 years, but it came to prominence only now. So only because of all these diseases, emerging diseases. So that is everything. So one more thing. So statistics is a data science for the 21st. This was actually a paper presented by the president of the Royal Statistical Society in 2015. So 5 years back. So the president of the Royal Statistical Society UK presented this paper, Statistics and Data Science for the 21st Century. So it has now his prediction has come to be reality now. So now in 2020 or 2019 onwards, data science and data analytics have come to the forefront. Many of the colleges are going to start this type of courses. So that is actually to help biostatisticians. It won't affect the job opportunities for biostatisticians. So now this is training the next generation of biostatisticians. So that is actually something very important. So the next generation of biostatisticians should be trained in advanced statistical theory and data science methods, including special topics like clinical trials, survival analysis, meta-analysis, crossover designs, MCS, Markov chain, Monte Carlo methods, etc. Then they should also be experts in data analytics, genomics, bioinformatics, and computational biology. They should have communication skills. They should be good experts in communication. Legal knowledge and leadership skills are also essential for every biostatistician, especially biostatisticians in the industrial sector. I will just show some of the opportunities, job opportunities. So biostatisticians Job opportunities are in pharma industry, primarily in pharma industries, then as teachers, clinical researchers, clinical trials, actuarial science and finance and banking. In insurance companies also biostatistics are needed. So usually it is referred to as actuarial science. And now risk analyst, public health, government statistician, research and teaching, project management, cancer research, AIDS modeling, COVID-19 research, disease modeling, disease mapping, public health, epidemiology, genomic studies, statistical computing, consultancy, market research, business analytics, official statistics, everywhere this biostatistics is going to be made use of. So here is a reference. So these are actually some of the reference papers which I have made use of. Some reference papers which have appeared recently in the biostatistics. This is a paper which appeared very recently in the Clinical Epidemiology and Global Health journal. This is actually by our students who have undergone biostatistics MSc course here, and they are presently doing their research at Christian Medical College, Vellore. So their studies actually for forecasting COVID-19 epidemic in India and high incidence states like this Maharashtra, then Delhi, then Tamil Nadu. Certainly, their theory was applied in Kerala also. So with Sri T.K. Jose IAS in charge of this COVID monitoring, he actually made a special request to me, and we contacted our students, and they made the predictions, and the predictions came to be true also. So that is actually something which I want to share with you. So this biostatistics study, if you want to get up, it is good. If you want to go for research, it is good. And regarding the techniques, so you could be a good programmer, you could be a good scientist, a statistician, and everywhere. You could be a good manager, you could be a good team leader, and so on. So I conclude with this one. So once again, I conclude this data is powerful. So that people have understood, people have realized the importance, industry have realized the importance of data. Data is powerful, better data, better lives. So you have to collect better data. Then only you can arrive at better decisions and then better lives. So your lifestyle business. So biostatistics for health, wealth, and welfare. That is what that is the usual slogan. Biostatistics for health. Then if there is health, certainly there will be wealth, and then there will be welfare in the community. Thank you all. Thank you. Hello.
Thank you, sir.
Hello.
Sir, can you hear me?
Hello. My talk is over, madam. Shiny madam. Hello.
Okay. Any
Can
questions,
see
any
me?
doubts, students, participants?
I cannot hear.
Any doubts?
Sir, can you?
Sir, it's
So
audible.
sorry for the problems in the beginning.
You cannot hear?
Cannot hear?
Can you hear me?
Yes.
Any doubts, participants?
Can hear?
If you have any doubts,
Okay, thank you, sir. Now,
Hello?
yes, sir, we can hear you.
Echo.
I would like to invite Dr. Shiny Jones, convener, ICT,
Hello?
to deliver the vote of thanks.
Good afternoon,
Hello there.
everybody. 20th October, yesterday, World Statistics Day. We have the apt resource person, Dr. K.K. Jose, to commemorate the
hear
World
me?
Statistics Day. Famous academician and an administrator.
Hello?
He was the former principal of St. Thomas
Hello,
College,
Pradile.
Pala. Sir, you had gone through the application of biostatistics in medical field during this COVID-19 scenario. Sir, I extend my sincere thanks on behalf of Kerala Mathematical Association and on behalf of all the participants present here. Thank you, sir. Thank you very much. Now this session over. We can meet tomorrow on different link. We'll give you another link. Thank you, sir.
Thank you. Now we are going to wind up today's session. We will start our third session tomorrow by 10 a.m. So thank you all participants.
Hello.